Hello, 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 hello. Give me a watch. Can I have a watch, please? I'll keep a yeah or a cell. You don't have? हाँ watch दे दीजिए. जैसे यहाँ रखने के लिए चाहिए. Thank you. Yeah. Good afternoon. I'm Dr. Shalini Bakshi. I teach in Delhi University, and I'm a physical chemistry expert. Today, what I'm going to be doing is taking the mole concept a little further and dealing with equivalent. Just the idea of equivalent and how we calculate equivalent in various conditions. And I'll also be, time allowing, I'll also be introducing the concept of normality, right? I think both these ideas are very new to you. Are they? Even normality, right? The terms of concentrations, you use molarity, you have used molarity, right? And have you used molality, small m? But normality is new, is it? Okay. So basically in chemistry, the concept of equivalent is very important. And also the concept of normality. All the reactions that you do, all the titrations that you do, normally use normal solutions, right? And that's where the equivalent concept comes into play. Hmm? So how I've divided my lecture is that we're going to begin with the historical importance of equivalent as to what we really mean and what is the need of equivalent. How did it historically arise? The reason why any topic's historical relevance is important is because अगर आपको ये नहीं समझ आता कि कोई टॉपिक आया क्यों था या उसकी ज़रूरत क्या पड़ी या उसने सॉल्व क्या किया तब तक आप उसमें उसको प्रॉपर्ली अप्लाई नहीं कर सकते. So the first section talks about the historical importance. Then we go on to the definition of how we define equivalence or equivalent, and then we go on to the various ways in which equivalent are calculated. So we will look at how what we terms or how we calculate equivalent weight of an acid, for a base, for a salt, then the different types of reactions, so for redox and non-redox reactions, right? We've taken some examples, just keeping the time frame right in mind, and then I've gone on to also look at the different scenarios of equivalent weight, as in how we can calculate the equivalent weight of a metal, which is what is described in your books also. So different examples and different calculations based on that, and how we can use it. So I have some examples based on the usage of those formulae that have been given there, right? And then we move on to the concept of normality. Why is normality important? Is because when we are dealing with solutions, what is a solution? A solution is a mixture, right? Homogeneous of solute and a solvent. So when we want to express the concentration, you can't do it of a pure substance. It doesn't have any meaning. You only talk of concentration of a solution. And when in a very basic term, what does concentration mean? How much in how much, right? So there are various ways in chemistry in which you express this. For example, percentage by weight, percentage by volume, mass by volume, right? Parts per million, molarity, which is capital M, molality, which is small m, and then normality. Why are we dealing only with normality today? Because because it directly links to the concept of equivalent weight. Historically, Molarity came much later than normality. The concept of equivalent weight was where chemistry began from. Right? So that is roughly what I'm going to do today. Is that clear? Any doubts? Now, moving on to, as I said, the historical. One of the greatest problems was the reaction of hydrogen with oxygen to produce water historically. And it was seen that when 1 gram of hydrogen reacts with 8 grams of oxygen, 9 grams of water were produced, and therefore equivalent weight of oxygen was described as 8 grams. It was described as the mass of oxygen or the weight of oxygen which reacts with one part of hydrogen. This is one of the first definitions of equivalent mass or equivalent weight of oxygen. Equivalent weights were not without problems. For a start, the scale based on hydrogen was not particularly practical. Why? Can you see the first paragraph was in terms of the reaction of oxygen with hydrogen. Is that right? But everything doesn't react with hydrogen. In fact, there are very less elements which react directly with hydrogen. So that was the problem in defining everything with respect to hydrogen, right? Equivalent basically means in relation to, so it is a relative thing. So when you say H with O giving you water, you're defining oxygen's equivalent weight in terms of how much of it reacts with one part of hydrogen. So it would have been okay if you would have had a series of elements reacting with hydrogen. But because you don't, therefore what we had to do, most elements don't react. However, 1 gram of hydrogen reacts with 8 grams of oxygen to give water, or with 35.5 to give HCl. Therefore, 8 grams of oxygen and 35.5 grams of chlorine could also be taken as equivalent for 1 gram of hydrogen. This is the most important part for you to understand. Because when you look at a definition, which is also given in all the books, including yours, the first definition that it says is the amount with one part of hydrogen, 8 parts of 35.5 parts of chlorine, and one doesn't understand what the reason for this is, right? So one must understand the historical reason for the originating of oxygen and chlorine as reference points, because everything had to be defined with respect to something and with reaction with something, and therefore it was essential that आपने एक बार ऑक्सीजन को डिफाइन कर दिया तो आपके पास ऑक्सीजन के 8 पार्ट्स भी एक रेफरेंस पॉइंट बन गए. तो जो चीज डायरेक्टली रिएक्ट नहीं कर रही है, आप उसे देखते हैं कि 8 पार्ट्स ऑक्सीजन से कितने पार्ट्स एक्चुअली रिएक्ट कर रहे हैं ऑफ एनी अदर एलिमेंट, दैट बिकम्स द इक्विवेलेंट ऑफ दैट पर्टिकुलर एलिमेंट. डू यू अंडरस्टैंड व्हाट आई एम सेइंग? If 8 parts are reacting with 1 part of hydrogen, 8 parts become the equivalent weight of oxygen. इसी तरह से कोई और एलिमेंट जो भी उसके साथ ऑक्सीजन के साथ रिएक्ट कर रहा है, वो जरूरी नहीं है कि वो 8 पार्ट्स के साथ ही रिएक्ट करे. इट कुड रिएक्ट इन एनी ऑफ देयर सिंपल रेशियोज. बट हैविंग वर्कड आउट द इक्वेशन, वन कैन फाइंड आउट कि 8 पार्ट्स से कितना रिएक्ट करेगा. तो जितना भी वेट 8 पार्ट्स के साथ रिएक्ट करता है, दैट बिकम्स द इक्विवेलेंट वेट ऑफ दैट पर्टिकुलर एलिमेंट. Is that idea clear? Have you understood? Similarly, you extend it to 35.5. Why does 35.5 come in? Because 35.5 parts of chlorine is reacting with 1 part of hydrogen. So that again becomes a reference point. Is that clear? So that was the historical importance. Now, this is the table that was there, which was one of the very old tables of equivalent weights that was historically present or historically presented. Now, if you can see here, the equivalent weights of elements are often determined by studying their reactions with oxygen. Why? Can you answer why? Can you answer why? The first line. Why equivalence? You understand why equivalent weights need to be determined by reaction, first of all? Because the whole concept is based on reactions. How much is reacting with X parts of what you have defined as standard? Do you understand the concept of equivalent? That is what will help you in numerical solving also. The base has to be clear of any concept. Then you can build on it. Is that right? So what one is saying in equivalence is how much is reacting with X parts or whatever you've called as standards. So the question I'm asking is, why was it important to study the reactions with oxygen? So why only oxygen? Why not anything else? Yes, because mostly elements react with oxygen to form oxides, right? So mostly they were converted into oxides and then their calculation was done, right? Because आपने oxide बना लिया, आपके पास उसका मास आ गया, अब आप कैलकुलेट कर सकते हैं कि 8 पार्ट्स के साथ कितना अमाउंट ने कैलकुलेट किया, कितने पार्ट्स ने कैलकुलेट किया, वो उसका इक्विवेलेंट वेट बन जाएगा. इज दैट क्लियर? I have an example also. For example, 50 grams of zinc reacts with oxygen to produce 62.24 grams of zinc oxide. If you write that down in your copies, 50 grams of zinc reacts with oxygen to give 62.24 grams. Is that right? So that means the other way the question could have been asked was 50 grams produces 62.24 grams of metal oxide. Now what you have to find out is the equivalent weight of zinc. तो आप कैसे निकालेंगे? आपको पता है कि 12.24 ग्राम्स ऑफ ऑक्सीजन जो है वो 50 ग्राम्स के साथ रिएक्ट कर रहा है, तो 8 पार्ट्स कितने के साथ करेगा? So that is my calculation. Is that right? 50 upon 12.24 into 8. Is that clear? Have you understood? 12.24 कहाँ से आया? Because I have subtracted the mass of metal oxide minus the mass of metal. So I get oxygen. Is that right? So I know how much oxygen is combining with how much zinc. So from that ratio, I can find out how much will combine with 8 parts. Why with 8 parts? Because 8 parts of oxygen combined with one part of hydrogen to give water. That is why 8 parts. If a different amount had reacted, I would have calculated different. It should be clear why only 8 parts. Have you understood? Right? So this was again historically calculated, and this came out to be 32.7. Does that calculation make sense to you? Have you been able to calculate it? Okay, great. Now comes some fundamentals about equivalent mass and equivalent weight. In chemistry, we find we are using both. Like I have also deliberately in my 20 sentences or 50 sentences used both. Because equivalent mass and equivalent weight for a chemistry person mean the same thing. They can be used either way. For a physics person, it means completely different, right? A mass is inherent property in physics. Weight is a force, right? Weight is m into g. But in chemistry, equivalent mass and equivalent weight mean the same thing. Have you understood this? Okay. Now coming to law of chemical equivalence. Now when we talk of law of chemical equivalence, is there a duster? Oh, okay. If you have a general reaction, is that right? How do we define law of chemical equivalence? We define it as that 1 gram equivalent of A will react with 1 gram equivalent of B to produce 1 gram equivalent of C and 1 gram equivalent of D. There is a ratio in chemistry that is applicable. I think you have already undergone the class on stoichiometry. Have you? Right? You have done stoichiometry, limiting reagents and so on. You have done that. Have you? बड़े आधे आधे आंसर्स मिल रहे हैं. Okay. So you have looked at stoichiometry in terms of moles, and you have also looked at stoichiometry in terms of molar volumes. Is that right? Now you have seen that there is no random combinations between elements. They all happen in a specific ratio. So that is where the law of chemical equivalence comes from. That every combination happens in a ratio. So 1 gram equivalent of A in this particular equation will combine with 1 gram equivalent of B to give 1 gram equivalent of C and 1 gram equivalent of D. Now, why is the concept of equivalent important, and how do we use it in our daily lives also? You know how all of us understand how we use recipes to make food? All of us have used it. आप लोगों ने घर पे यूज करें स्टैंडर्ड रेसिपीज जब आप डाउनलोड करते हैं इंटरनेट से, उसमें एक रेशो गिवन होता है, राइट? लेट्स से ऑफ एनीथिंग, like for example, let's say you're making something sweet, so that it'll have sugar, it'll have a flour, it'll have whatever else that you're putting into, and there'll be ratio specified: 2 cups, half a spoon, 3 teaspoons, and so on. And then it is always mentioned at the end how many people it will serve. Is that correct? So it'll say, it'll always tell you, a good recipe will always tell you, otherwise you don't know what you're making for. You could be producing something very large in quantity or something very small. So normally it'll say it is serving 4 people. Now, if you are catering to more than that, if you're catering to a larger audience, if you have more guests coming in, तो आप क्या करते हैं? उसी को उस particular factor से multiply कर लेते हैं, और यही करते हैं हम equivalence में. This is the whole concept of equivalence. This is the relevance of equivalence. You know the basic ratios, you know the basic concepts, and now you can scale up, you can also scale down. अगर आपको 4 लोगों के लिए रेसिपी पता है तो आप 2 लोगों के लिए भी बना सकते हैं. Is that right? So that is how the equivalent concept is useful. Now coming to some other properties of equivalent thing. First of all, an equivalent weight, unlike atomic weight, is variable. Equivalent weight is not a fixed. Atomic masses constant होते हैं ना. जैसे मैं आपसे पूछती हूँ atomic mass सल्फर कितना है, बताइए. आप ये नहीं बोलते ना, आप बताइए कि सल्फर कहाँ यूज कर रहे हैं. ये तो आप मुझसे नहीं पूछ रहे ना. 32 है. एटॉमिक मास ऑफ आयरन कितना है, बताइए. ये तो टिप्स पे होना चाहिए. 56, राइट. तो ये भी अगेन इट्स एन इंडिपेंडेंट क्वांटिटी, बट इक्विवेलेंट वेट विल वेरी. इट विल वेरी विद वैलेंसी. इट विल आल्सो वेरी विद मीडियम. दैट विल सी लेटर, राइट. जैसे हम KMnO4 की जब इक्विवेलेंट वेट वहां पे कैलकुलेट करते हैं, वो डिपेंड करता है कि आप अल्कलाइन मीडियम में ले रहे हैं, एसिडिक में ले रहे हैं या न्यूट्रल में ले रहे हैं. हर पे वो केस डिपेंड करता है. उसी तरह वैलेंसी भी डिपेंड करता है. जैसे आयरन का केस लिया, आयरन का एटॉमिक मास इज 56, लेकिन इक्विवेलेंट वेट डिपेंड करेगा. ठीक है, वी विल सी ऑल दोस थिंग्स. सिमिलरली किस तरह के रिएक्शन में वो आ रहा है, किस तरह के रिएक्शन में वो किस तरह के प्रोडक्ट्स प्रोड्यूस कर रहा है, कितना रेशो में रिएक्ट कर रहा है, उन सब के ऊपर इक्विवेलेंट वेट्स डिपेंड करते हैं. Therefore, it makes it slightly more complex and slightly more interesting. Is that right? Why is this complex? Because for every case, you have to deal with it differently. But why is it interesting? Because that's how we are able to make a lot of en routes in chemistry. That's how we are able to figure out a lot of why stoichiometry is important is, do you know why stoichiometry is important? Why is it important? Yeah. Okay, great. For a medicine, your ratios are known. In industry, you know the output that you're going to get, right? So stoichiometry has a huge practical importance. It is not something that will stay contained within your copies. In everything that in chemistry, any chemical reaction का जो basic रहता है, that is stoichiometry. Because things are not randomly reacting, they're reacting in ratios. So you're able to scale up and scale down depending on those ratios. Is that right? So now we come to the formal definition, which is something that you will probably have to learn by heart, which is that number of parts of weight of a substance. Please add that, of a substance, which will combine with or replace directly or indirectly 1.008 parts by weight of hydrogen. Why does that figure come? That I think you know. Because वो आपका relative atomic mass table होता है, उसमें 1.008 आता है C12 के हिसाब से. 8 parts of oxygen, 35.5 parts of weight of chlorine, and 108 parts. So why is the silver come? From the same reason. जैसे 35.5 आया था. यहाँ तक clear है सबको? Is the definition now clear? Okay. Now we come to how do we get the equivalent mass of an element? Let's start with that. The most basic thing. How do we find out the equivalent mass of any element? The way that you figure out is atomic mass divided by its valency. और concept आया कैसे? जब हमने हाइड्रोजन, ऑक्सीजन और लेट्स से क्लोरीन का देखा, तो हाइड्रोजन का तो 1 आ गया सीधा. ऑक्सीजन came out to be 8 and this came out to be 35.5. So we have to understand where does this 8 come from? ये कहाँ से आया? Right? We didn't know the valency idea then. तो ये कहाँ से आया? How did we really arrive at the concept of 8? If you look at any element like let's say sodium, the example I have taken here, it forms sodium hydride, NaH. यहाँ पर 1 part of hydrogen combines with 23 parts of it combines with 23 parts of sodium. Is that right? When you look at Na2O, yeah, 16 parts of oxygen combines with 46 parts of sodium. Okay? And when I look at NaCl, 35.5 parts of Cl combined with 23 parts of sodium. Right? Now, when I want equivalent, I want the same mass of the element that combines with the same which is combining with one part of hydrogen. So with one part of hydrogen कितना combine कर रहा है? 23 parts. तो ऑक्सीजन का इक्विवेलेंट मास वो होगा जो 23 parts of sodium के साथ combine कर रहा है, which is 8. That is another way we can look at how we get 8. Do you understand what I'm saying? When I'm looking at equivalent mass of 23, equivalent weight या equivalent mass of sodium कितना है? 23. कहाँ से आया? It comes because in sodium hydride, it is 23 grams of Na that is combining with 1 gram of H. Is that right? So now in Na2O, सोडियम का इक्विवेलेंट मास या उससे ऑक्सीजन का कैसे निकालेंगे? वो मास जो 23 पार्ट्स ऑफ सोडियम से कंबाइन करता है, which is how much? 46 is combining with 16, so 23 will combine with 8. Clear? Have you understood? That's another way we can reach this. So equivalent mass of an element is nothing but atomic mass of the element divided by the valency. That is something we can use in general. Clear? Is it clear? Next, coming to, can you calculate the equivalent mass of iron? Please do it yourself. Atomic mass 56 है, equivalent mass कितना है? बताइए. 28? सबका 28? कुछ और? I'd rather involve you rather than just doing a monologue. बोलिए. Will it be 56 divided by 2, which is 28? But iron की दो valencies होती है. Yeah, so it will have two different equivalent weights. It will be 56 divided by 2 and 56 divided by 3. Right? So if the question comes as a multiple choice question, then you will have MCQs given, जिसमें एक option में दो numbers होंगे. So you need to figure out. Yeah, it can also be, two different options which can be correct. It cannot have one single equivalent weight. That's what I told you in the beginning. Na? The difference between equivalent weight and atomic weight is a constant quantity. Iron का 56 है, independent of whether it's ferrous or ferric. But when you look at equivalent, it depends on whether it is ferrous. So if it is ferrous, it is Fe2 positive. That means valency is 2. So it is 56 by 2. And if it is ferric, it is Fe3 positive. So it is 56 by 3. Clear? What happened? Can you hear? Aa rahi hai awaaz? Is it okay? Haan. Is it clear? Sorry. Clear? Is it clear till here? Okay. So similarly copper. Similarly all the D block elements जहाँ पे variable valencies होती हैं. ये कहाँ apply करेगा? अब आपको सोचना MCQs यही आते हैं. Reasoning questions यहीं से बनते हैं. सारे D and F block में, F तो आपको आते नहीं है normally. D block में ही variable valencies होती हैं. Unless you're talking of something like phosphorus जो D block में होते हुए भी 3 and 5 है. But normally D में variable valencies होती हैं. वहाँ पे आपके equivalent weights आपको multiple आ सकते हैं. Clear? Okay. Now coming to types of reactions. First, let's look at what are the different types of reactions. दो type of reactions की हम बात करते हैं, एक redox और एक non-redox. Redox कौन से होते हैं? जहाँ पे gain and loss of electrons is taking place. Is that right? Where you have an oxidation and a reduction reaction going on, an oxidizing and a reducing species, right? उनको हम बाद में deal करेंगे because redox is a little more complex because it talks in terms of electrons. First, let's talk in terms of non-redox reactions. So non-redox reaction में तीन cases आपने करने हैं. Equivalent weight calculate करना है आपने acid का, base का और salt का. सबसे पहले, ठीक है? So let's talk in terms of equivalent mass of an acid. When you want to calculate the equivalent mass of an acid, it is, and I'm talking of non-redox case. Please understand this. Acids can surface in redox reactions also. ठीक है? तो non-redox cases में equivalent mass of an acid is molecular mass divided by the basicity. And what is basicity? It is the number of replaceable hydrogen ions. क्लियर? हाइड्रोजन आयंस रिप्लेसेबल आपको देखने पड़ेंगे किसी भी स्पेसिफिक केस में, रिएक्शन को देखकर कि कितने हाइड्रोजन आयंस रिप्लेस हुए, एंड आई हैव एग्जांपल्स फॉर दैट, सो डोंट वरी अबाउट इट, वी जस्ट टेक इट अप. जैसे हमने इक्विवेलेंट मास या इक्विवेलेंट वेट ऑफ HCl निकालना है, तो हम कैसे निकालेंगे? मॉलिक्यूलर मास निकाल सकते हैं आप, दैट इज 35.5 प्लस 1 which is divided by 1. तो HCl में तो कोई प्रॉब्लम है नहीं because there is one hydrogen. Now in H2SO4 it is 2 into 1 plus 32 plus 16 into 4, तो 98 divided by 2. Clear? So this comes out to be 49. तो वो उसका 1 हो गया, equivalent mass of H2SO4 becomes 49. Clear यहाँ तक? अब जरा आप ये खुद करिए. हाँ. आप बताइए एटॉमिक नंबर क्या होता है? 15. अब सोचिए 31. बड़ी बार एटॉमिक नंबर से यू आर एबल टू रिलेट इट, बिकॉज फॉस्फोरस से पहले एलिमेंट क्या होता है? सिलिकॉन 1428, सल्फर 1632, phosphorus 1531. Please remember these atomic masses, you must know. आप मुझे ना ओवरऑल बताइए, मतलब मॉलिक्यूलर मास डिवाइडेड बाय कितना होगा फॉस्फोरिक का और दूसरे का? And I'd like everyone to be involved. किसी को भी नहीं समझ आ रहा तो that's not okay. कितना है वो? बताइए. फर्स्ट वन का क्या है? 98 है H3PO4 का, डिवाइडेड बाय, एंड उसमें okay. So number of replaceable hydrogens according to you in the next case, orthophosphorus acid is also whatever its molecular mass is divided by 3, because in both the cases there are 3 replaceable hydrogens, but that's not true. That is not true. The reason for that is that in this case, तो आपका structure ये है. Let me just take it on this. H3PO4 ये है structure, right hand side वाला जो मैंने यहाँ बनाया. ठीक है, इसमें तो 3 replaceable hydrogens हैं, so that is fine. 98 divided by 3 is fine. Molecular mass divided by 3 because 3 replaceable hydrogens है. जो आपका H3PO3 है उसमें 3 replaceable hydrogens नहीं है. It has got only 2 replaceable hydrogens. This is a very, very important question. Do you understand what I'm saying? In H3PO3, in this is the structure of H3PO3. इसके अंदर सिर्फ 2 replaceable hydrogen है, 3 नहीं है. Why? What is the reason? Why? When is hydrogen replaceable? When it is attached to an electronegative element. आप जब एसिडिटी की बात करते हैं तो H is getting removed as H positive. H positive वो कब रिमूव होगा? जब वो एक ऐसे एलिमेंट के साथ अटैच्ड है जो इलेक्ट्रॉन पेयर को होल्ड कर लेगा और H को H पॉजिटिव रिलीज कर देगा. यही है ना? Isn't that correct? ठीक है, और फिर वो कॉन्जुगेशन भी कर लेगा यहाँ पे, कुछ आपका जो स्ट्रक्चर बचेगा वो स्टेबल हो जाएगा, बिकॉज वहाँ पे वो नेगेटिव बचेगा, दैट कैन फॉर्म अ डबल बॉन्ड, वो शिफ्ट इन द सेंस इट कैन बी स्टेबल, बट दैट आल्सो यू डोंट हैव टू वरी. As long as your H is attached to an electronegative element, it can be released as H positive. When it is attached directly to phosphorus, तब it cannot be released as H positive. You understand? Because this electron pair is pretty evenly shared between P and H. If you look at the electronegativity table, H and P are not that widely apart, like H and oxygen. Electronegativity table क्या बताता है? Electronegativity is the ability of an atom to attract the shared pair of electron towards itself. Oxygen is a highly electronegative element. It's almost at the top. It's not the highest, but it is almost very high. क्लोरीन से सेकंड है बस. इज दैट राइट? तो वो क्या करता है, शेयर पेयर ऑफ इलेक्ट्रॉन को पूरा अपनी तरफ खींच लेता है, तो H को एज H पॉजिटिव रिलीज होना बहुत आसान हो जाता है. बट व्हेन इट इज P एंड H नहीं रिलीज हो पाता. तो ये H जो है वो एसिडिक हाइड्रोजन नहीं है, एंड देयरफॉर H3PO3 की बेसिसिटी इज 2, एंड देयरफॉर इट्स इक्विवेलेंट वेट इज मास अपॉन 2. क्लियर? ये बहुत इंपॉर्टेंट है, मार्क कर लीजिए इसे, बहुत आता है एग्जाम में. And it can come as any form. Okay. Now coming to equivalent weight mass of a base. जैसे वहां पे H positive था, यहाँ OH minus है. Is that correct? So this is molecular mass upon the acidity of a base. And what is acidity? Just like basicity of an acid was the number of replaceable hydrogen ions, acidity of a base is number of replaceable hydroxyl ions, which can vary from case to case. ये सबसे important बात है. हर केस में सेम नहीं होगा. आप सिर्फ एसिड या बेस को, इसीलिए मैंने पिछला एग्जांपल कराया था, सिर्फ एसिड और बेस को देख के वहां पे H और OH कैलकुलेट नहीं कर लेंगे. यू हैव टू थिंक ऑफ मोर देन दैट. क्लियर? नाउ ये सिंपल केसेस है. सोडियम हाइड्रोक्साइड एक OH माइनस फर्निश करेगा, तो उसकी बेसिस, उसकी एसिडिटी 1 है. कैल्शियम हाइड्रोक्साइड 2 करेगा, तो 2 है, डिवाइड मॉलिक्यूलर मास डिवाइडेड बाय 2. और एल्यूमिनियम हाइड्रोक्साइड 3 करेगा, तो इट्स मॉलिक्यूलर मास डिवाइडेड बाय 3. ऑल द 3 केसेस क्लियर? लिख रहे हैं बात कीजिए. कैन यू कैलकुलेट AlOH थ्राइस का इक्विवेलेंट वेट? करिए. लॉस्ट में अगेन. Okay, now just try this. Calculate the equivalent weights. लिखिए ये question. Write it down. Calculate equivalent weights of H2SO3. यहाँ मॉलिक्यूलर मास कैलकुलेट कर दिया मैंने, नॉर्मली नहीं कैलकुलेट होता. ये रिएक्शन गिवन है, इसमें आपको दोनों स्पीशीज एसिड और बेस की इक्विवेलेंट वेट कैलकुलेट करना है. क्लियर? क्वेश्चन इज क्लियर? हाँ, दूसरा क्वेश्चन लिखिए. Now, why I've given you these two questions is because the first one is simple, except that you find different looking acids and bases. So, one has a tendency sometimes to get confused. In the second example, you have the same acid and base. नाइट्रिक एसिड का आप इक्विवेलेंट वेट खुद कैलकुलेट कर सकते हैं, ठीक है, लेकिन दोनों जगह पर एसिड और बेस डिफरेंटली रिएक्ट कर रहे हैं, मतलब यू हैव टू डिफरेंट रिएक्शंस, तो दोनों केसेस में इक्विवेलेंट वेट फर्क हो जाएगा. डू यू अंडरस्टैंड व्हाट आई एम सेइंग? पहला केस तो एक ही केस है, वो क्यों दिया था? बिकॉज एसिड बेस डिफरेंट है. ये इसलिए दिया है बिकॉज वही एसिड और बेस एक से ज्यादा रिएक्शन में पार्टिसिपेट कर रहे हैं. तो मैंने आपको पहले 2-3 स्लाइड्स में बोला था इक्विवेलेंट वेट्स डिपेंड करते हैं वैलेंसी पे, जिसका आपने एग्जांपल कर लिया. दूसरा ऑन द टाइप ऑफ रिएक्शन, ये उसका एग्जांपल है. जस्ट ट्राई इट आउट. पहले का बताइए. H2SO3 का इक्विवेलेंट, ओह सॉरी, आई एम सो सॉरी. दिख रहा है? नहीं दिख रहा है. Thank you so much. बताइए, पहला बताइए. H2SO3 का इक्विवेलेंट वेट क्या है पहले केस में? 41. Have all of you got it? Great. Because it is 82 divided by 2. Because both the hydrogen ions are participating. दूसरे केस में क्या है? 24. Fine. Because there is only one hydroxyl ion. So that's a simple case. दूसरा बताइए. पहले केस में HNO3 प्लस गैलियम हाइड्रोक्साइड, जो फर्स्ट रिएक्शन है, उसमें क्या होगा इक्विवेलेंट वेट ऑफ HNO3? बताइए, पहले केस में क्या होगा? हाँ, we are just calculating the equivalent weight of the acid and the equivalent weight of the base, right? हाँ, 63 होता है, बिल्कुल ठीक है. इक्विवेलेंट वेट आपका मॉलिक्यूलर मास 63 है. HNO3 में कितने रिप्लेसेबल हाइड्रोजन है? 1. एक ही पार्टिसिपेट कर रहा है, so it's 63 divided by 1. You don't have to worry about the stoichiometric coefficient, if that's what you're asking me. No. One H positive is participating. That's why I gave you these questions. One H positive is participating, so it becomes 63 by 1. Clear? Okay. Next, what is gallium hydroxide? उसका कितना होता है? आपको molecular mass given है 121. 121 by 3. Second case में क्या है? 121 by 3. 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 नहीं, ये तो हो गया 121/3। आई एम टॉकिंग ऑफ द सेकेंड रिएक्शन। इस वाले में इक्विवेलेंट वेट क्या है HNO3 का? पहला तो 63 है, बिकॉज देयर इज ओनली वन आयन विच इज पार्टिसिपेटिंग। दूसरे का क्या होगा? 121 only. Absolutely, very good. 121 only. Why? Because only one hydroxyl ion is participating. Can you see that? राइट हैंड साइड में आपके पास जो गैलियम का कॉम्प्लेक्स है उसमें दो हाइड्रोक्सिल आयंस आर जॉइंड विद गैलियम। दैट मींस रिएक्शन में सिर्फ एक हाइड्रोक्सिल आयन पार्टिसिपेट कर रहा है। यू डू नॉट हैव टू वरी अबाउट द स्टोइचियोमेट्रिक कोएफिशिएंट्स हियर, यू डोंट। आपके लेफ्ट हैंड साइड में 3 हाइड्रोक्सिल आयंस है, राइट हैंड साइड में 2 अभी भी जॉइंड है। यहाँ है जॉइंट? नहीं है ना। पहले वाले में कंप्लीट रिप्लेसमेंट है ना नाइट्रेट आयन की, तो सारे हाइड्रोक्सिल आयन पार्टिसिपेट कर गए। यहाँ पे कितने पार्टिसिपेट कर रहे हैं? आउट ऑफ 3 सिर्फ 1 पार्टिसिपेट कर रहा है, 2 रह रहे हैं। तो इसलिए नंबर ऑफ रिप्लेसेबल हाइड्रोजन हाइड्रोक्सिल आयंस इन द सेकंड केस कितने हैं? 1। तो आपका इक्विवेलेंट वेट कितना हो जाएगा? 121/1। क्लियर? समझ आ गए केसेस? ठीक है। नाउ यू कैन, आई होप, फाइंड आउट or any acid, any base in a reaction without worrying about what is happening overall, just looking at how many hydrogen and how many hydroxyls are participating. So I hope it's clear that equivalent weight is so dependent on whichever reaction that you're considering and whichever element and whichever oxidation state you're looking at. ठीक है, तो 2 cases हमने इसके डिस्कस कर दिए। Now let's come to equivalent mass of a salt. Now when you're looking at equivalent mass of a salt, it is molecular mass of the salt, right? You know what a salt is, first of all. What is a salt? What is a salt? सबसे बेसिक डेफिनेशन ऑफ सॉल्ट क्या होती है? Acid and a, right, absolutely. A compound formed by the neutralization reaction of an acid and a base is a salt. So when we are trying to find out the equivalent weight of a salt, we take the molecular mass of the salt and divide it by the total number of positive valencies. कई बुक्स में या कई रेफरेंसेस में आपको दिखेगा that it is total number of positive valencies or total number of negative valencies. In a salt, I hope you know that salt is overall a neutral species. Therefore, the positive and the negative valencies are equal, so it doesn't matter. But by convention, the definition is molecular mass of a salt divided by total number of positive valencies. A lot of times students make mistake because they add up the valencies, positive and negative. वो नहीं करना है आपने. You have to take one set of valencies. Is it clear? Now NaCl में it becomes by 1. Why? Because positive valency is +1. इसमें 2 because calcium is +2. Is that clear? अगर नेगेटिव वैलेंसीज लेते तो Cl क्योंकि 2 हैं तो आप -1 नहीं लेंगे, इट विल बिकम -1 into 2, so -2. टोटल चार्ज क्या है? -2. क्लियर? Positive valency बोलते हैं, but that is considered as oxidation number only in most cases, but it is stated as positive valency. ठीक है? Now can you do this yourself? जो मैंने लास्ट एग्जांपल्स अभी एक्सप्लेन करे, you will require them to solve this. और इसका मास भी कैलकुलेट करिए. गलत। जब कोई टीचर क्वेश्चन करवाती है इसका मतलब कि उसमें कुछ है ऐसा, तभी करवा रही है। सो लुक फॉर दैट। अभी मैंने कुछ पीछे आपको बताया था एंड आई वाज श्योर कि आप लोग उसे भूल जाओगे। Divide molecular mass divided by what factor is what I want to know. 3, 6. Why? With each having valency of, yeah. अभी I told you CaCl2 में कैल्शियम क्लोराइड में मैंने क्या बोला था कि Ca is +2. I hope you understand the difference between, where have I kept the marker? समझते हैं ना ये difference? Right? When you write 2CaCl2, right? Or when you write CaCl2, ये फर्क है ना concept? Right? You understand the difference? यहाँ पे जब हम कैल्शियम की वैलेंसी ले रहे हैं दैट इज +2, राइट, एंड क्लोराइड की वैलेंसी इज -1, बट देयर आर टू सच एंटिटीज। तो अगर मैं नेगेटिव वैलेंसीज ले रही होती, दैट्स व्हाई द फॉर्मूला वाज मॉलिक्यूलर मास डिवाइडेड बाय टोटल नंबर ऑफ पॉजिटिव वैलेंसीज और नेगेटिव वैलेंसीज इन सर्टेन रेफरेंस बुक्स दैट्स गिवन। तो आप इसको -2 से डिवाइड करते हैं या 2 से मॉड्यूलस लेते हैं हम उसका, तो 2 से डिवाइड करते हैं। उसी तरह से व्हेन यू आर लुकिंग एट Fe2SO4 thrice, तो फर्स्ट ऑफ ऑल तो यू नो दैट इट्स वैलेंसी स्टेट और इट्स ऑक्सीडेशन स्टेट इज +3. दिस इज अ फेरिक सॉल्ट, ये तो क्लियर है, एंड देयर आर 2, सो इट इज +6. तो टोटल वैलेंसीज क्या है? +6. और नेगेटिव वैलेंसीज भी आप देख लीजिए कितनी होंगी। सल्फेट का क्या होता है? -2, so it will be -6. Is it clear? So the division is not by 3, it is divided by 6. Please check it from both the sides. समझ रहे हैं? Al2SO4 thrice would be another example like this. समझ आया? Is it clear? Is it clear? और कौन से सॉल्ट्स आप जानते हैं बताइए, कुछ और एग्जांपल्स बताइए सॉल्ट्स के। बेरियम नाइट्रेट, बेरियम नाइट्रेट का क्या फॉर्मूला होता है? BnO3 होल ट्वाइस, तो वहां किससे डिवाइड करेंगे? 2. Is that clear? Let's discuss some more. Aluminium sulfate formula, thrice, right? ठीक है? Now is it clear? Okay. Now let's move on to gram equivalent mass. What is gram equivalent mass? The mass of a substance in grams which is equal to its equivalent mass. इसको हम gram equivalent mass बोलते हैं। जैसे अभी तक जब हमने निकाला था शुरू में equivalent mass of H2SO4, तो आपने आगे लिखा था 49. It had no subscript, it had no unit. When we say gram equivalent mass, it is the mass in grams which is equal to the equivalent mass. So that becomes 49 grams. So you have equivalent का idea, which is in terms of parts. When you say gram equivalent, it is in terms of grams. Is it clear? इसे हम further develop कर सकते हैं into mole concept and so on, but that part you have already done, so I don't want to repeat it. But basically that's the idea. So number of gram equivalents is mass of a substance divided by gram equivalent mass. Is this idea clear now? Let's spend some time on this. यही हमारा सेंट्रल आइडिया है नॉर्मैलिटी का। पहली बात, आपको वो कॉन्सेप्ट समझ आ गया? जैसे आप बोलते हैं कि for example HCl का equivalent mass is 36.5, gram equivalent mass is 36.5 grams. Fine. Now when we say number of gram equivalents, it's the mass of any substance. That mass could be anything divided by gram equivalent mass. जैसे कि जब हम कहते हैं number of moles, तो क्या होता है? Given mass upon molar mass. Is that right? या given mass upon atomic mass, depending on number of moles आप element के निकाल रहे हैं या compound के. उसी तरह से number of gram equivalents is given mass, right? या mass of the substance, एक ही बात है, upon gram equivalent mass. Is that right? इसी से आप उसके number of gram equivalents निकालते हैं. ये और ये ideas similar है. ये आइडिया आपको मोलर से लिंक करता है, ठीक है? नंबर ऑफ मोल्स लिंक्स यू टू मोलर मास. इट इज द मास डिवाइडेड बाय मोलर और एटॉमिक मास. उसी तरह से नंबर ऑफ ग्राम इक्विवेलेंट्स किससे लिंक करता है? ग्राम इक्विवेलेंट मास से. क्या रिलेशन है उसका? गिवन मास अपॉन द नंबर ऑफ ग्राम इक्विवेलेंट मास. ठीक है, अभी हम इसके प्रॉब्लम्स विल डू लेटर ऑन. फाइन, नाउ लेट्स मूव ऑन टू द नेक्स्ट पार्ट. Calculate the gram equivalent mass of 73 grams of HCl. करिए जरा. Very good. तो इसको हम क्या लिखेंगे? 2 ग्राम इक्विवेलेंट्स. ठीक है, 2GeQ. इज दैट राइट? यहीं से आपका नॉर्मेलिटी कॉन्सेप्ट आ जाता है. एक और प्रॉब्लम लिखिए. ये समझ आया कि नहीं आया पहले सबको? 73 ग्राम्स HCl में निकालना है. So gram equivalent mass of hydrogen is 1 gram, chlorine is 35.5, therefore gram equivalent mass of HCl is 36.5. Put it in this formula. Given mass is 73 divided by 36.5 comes out to be 2, right? Calculate the gram equivalents, number of gram equivalents present in 196 grams of H2SO4. Calculate the number of gram equivalents present in 196 grams of H2SO4. टू कैसे? 4. Equivalent mass of H2SO4 is 98 divided by 2, which is 49. क्या करा आपने लास्ट में? Can you explain what you had done? Divide by 98 कर दिया था, right? So you have to use whatever you know till now, ना? You have to calculate the. सबसे पहले जैसे ग्राम इक्विवेलेंस की कैलकुलेशन आए, you have to first calculate the equivalent weight of the species given. That's why I gave you this, right? Equivalent weight एक बार species की आ गई, तब आपने डिनोमिनेटर में आपके पास आ गया, न्यूमरेटर में गिवन मास है, तो आपके रेशियो से नंबर ऑफ ग्राम इक्विवेलेंट्स आ जाएंगे. इज इट क्लियर? इज इट क्लियर टू ऑल ऑफ यू? H2SO4 का ग्राम इक्विवेलेंट मास कितना है? कैसे? H2SO4 का मोलर मास कितना है? H2 is 2 plus 32 plus 64, 98. ठीक है. नंबर ऑफ रिप्लेसेबल हाइड्रोजन्स 2, तो इक्विवेलेंट मास 49. ठीक है, तो ग्राम इक्विवेलेंट मास 49 ग्राम्स, 196 by 49. Clear? So 4. Is it clear? Okay. Now let's move on. So we have finished one section. Now let's move on to redox reactions. Now, in redox reaction, normally we define something which is called as an N factor, right? What that N factor is you forget about the first term, normality by molarity, because we haven't discussed it yet. So just forget about that. But N factor basically is molecular mass divided by equivalent mass. तो फॉर एग्जाम्पल एन फैक्टर ऑफ सल्फ्यूरिक एसिड अगर उस पर्टिकुलर केस में हम देखें तो इट बिकम 98 डिवाइड बाय 49 सो इट बिकम 2. ठीक है, दैट इज ऑल. Don't get confused by additional terms. A lot of times students find additional terms very confusing. So N factor is nothing but a ratio of molecular mass and the equivalent mass. One of the easiest ways of understanding it. Now, what is an equivalent mass of an oxidizing and reducing species, reducing agents rather, right? अभी तक हम यही मैंने आपको शुरू में बताया था ना कि जब नॉन रिडॉक्स रिएक्शंस देखते हैं तो वहां पर आपके पास इलेक्ट्रॉन्स इन्वॉल्व नहीं होते, ठीक है. यहाँ पे आपके पास इलेक्ट्रॉन्स इन्वॉल्व हैं, तो योर डेफिनेशन चेंजेस टू दैट. So we say equivalent mass of oxidizing or reducing agent is the mass of substance in grams which loses or gains 1 mole of electrons. That is how you define it, right? You talk in terms of loss or gain of 1 mole of electrons. तो कितना mass 1 mole of electron change करता है, that is known as the equivalent mass. Do you understand what I'm saying? अगर आप एक रिएक्शन देख रहे हैं, ठीक है, उसमें आपकी जो ऑक्सीडेशन कर रही है स्पीशीज या जो रिड्यूस कर रही है, it is let's say losing 2 moles of electrons. How do you know that? आपने लिखा copper, आपने लिखा Cu going to Cu2 plus 2 electron. ऐसे लिखते हैं ना, right? Now in this particular thing, this 2 electrons can represent 2 electrons. It can also represent 2 moles of electron. Clear? So इसमें आपका इसका जो इक्विवेलेंट मास है वो कितना हो जाएगा? कॉपर का मॉलिक्यूलर मास होता है, किसी को याद है? 63.5, ठीक है, डिवाइडेड बाय 2. आ गया समझ? हैव यू अंडरस्टूड हाउ वी आर यूजिंग द नंबर ऑफ इलेक्ट्रॉन्स लॉस्ट एंड गेन? आपने रिएक्शन देखा, इलेक्ट्रॉन चेंज देखा, 1 है तो कोई दिक्कत नहीं है, अगर 1 से ज्यादा है तो जितना ज्यादा है that is represented the number of moles of electrons changing. See, any time you write down any reaction which is a balanced chemical reaction, it can be interpreted in many ways, जो आप लोगों ने stoichiometry में करा होगा. This can be read as 2 hydrogen molecules reacts with 1. It can be read as 2 moles of hydrogen reacting with 1 mole of oxygen. It can be read as 4 grams of hydrogen reacts with 32 grams, giving you 36 grams. It can be read as 2 into, you can convert it into molar volumes. So 2 into 22.4 liters at STP reacts with 22.4 liters of oxygen to produce 2 into 22.4 liters of water at STP. You have these various ways in which I can talk about this reaction. So it depends आपने क्या use करना है उस reaction को, ठीक है? Similarly, okay, I didn't know that. Yeah. So in case when you are looking at any reaction, for example, you're looking at a redox reaction, there also electron changes are taking place. Those electron changes can be multiple. They could be 1, they could be 2, they could be more than that. So for any species, when you're calculating the equivalent mass, it is its molecular mass divided by the number of moles of electrons that are gained or lost. Is it okay? Is it clear? Next, come to molecular mass divided by change in oxidation number of the element in 1 mole of a substance. That's another way of defining it. Because when the oxidation number changes, why does the oxidation number change in reactant and product? Do you know oxidation number? Do you know how to calculate it? So why does an oxidation number change? Loss or gain of electrons. So it's doing the same thing. When there is an there is a change in oxidation number here also. No? If you wanted to talk in terms of oxidation number change, we could have done that here also. It is going from 0 oxidation state to +2. So what is the change in oxidation number? 2. So we could have used that also. Answer would have remained the same. These are the different ways in which N factor or equivalent mass can be calculated. Is it clear? Have you understood this? Right? So equivalent mass, like these two definitions that have been given are to calculate equivalent mass. In the first case, equivalent mass is molecular mass divided by the number of moles that are changing. Second case is equivalent mass divided by the change in oxidation number, which basically means the same thing. Clear? Now we're going to apply this to determining the equivalent mass of KMnO4 in the different conditions. I hope you know this, that KMnO4, and this is my third example. I told you in the beginning that equivalent mass depends on what are the three factors? Valency, medium, and the reaction. So we did the reaction bit, we did the valency for iron, and this is now medium. Because now the medium is going from alkaline to acidic to neutral. And the equivalent weight of KMnO4 is changing. Clear? Now let's look at the first case. Right? Now this is my reaction in the acidic medium. Fine. What is equivalent mass? It is mass divided by N factor. How do we calculate that N factor? We calculate that N factor by looking at the change in oxidation number. Right? एक एग्जाम्पल अच्छे से समझ लीजिए, बाकी खुद करिएगा. पहला एग्जाम्पल पे KMnO4 जो है, you can see the manganese species, the manganese element in KMnO4 has an oxidation state of +7. Do all of you agree? Right? Just to make it clear, KMnO4 this is -8 +1, so this is +7. Right? Similarly, I can calculate manganese in MnSO4, that is +2. Sulfate is -2, Mn is +2. The change in oxidation number is of 5. So it is molecular mass divided by 5, N factor. So that is how much? Whatever the molecular mass of KMnO4 is, you can divide it by 5. The other way of doing it, the other way of very nice method of doing it is, if you look carefully, there are 5 nascent oxygens that are produced in the acidic case. Can you see that? On the right hand side, there are 5 O's that are produced. Okay? One atom of oxygen is 16 grams. So we can say 16 into 5 grams of oxygen are produced by 2 grams of KMnO4. Can you say that? Can you write this? 16 into 5 grams of oxygen is produced by 2 grams of KMnO4. Clear? Therefore, 1 gram is produced by 2 upon 16 into 5. And therefore, 8 parts of oxygen. Why we use 8 parts or 8 grams? Because of the equivalent concept. Right? So 8 grams will be produced by N by 5, which is the same answer that you're getting at the top. I'd like you to work this out yourself once. Write down the equation. Don't look at the solution. And work out the N factor and therefore the equivalent mass by both the methods. Is it done? Is this example clear? Is this example clear? No, it's not clear? Okay, let me explain it once again. Is the first part clear? That the oxidation number changes from +7 to +2. Is that clear? So you divide molecular mass by 5. Is that clear? Okay. Now, I'm saying 5 O are produced in the reaction. Can you see that? So 16 into 5. First of all, why are we taking O only? Because I had described in the first slides that when you're calculating the equivalent mass, you're calculating defined or with respect to how much of that is reacting with 8 parts of oxygen. Is that clear? जब हम उसी को ग्राम इक्विवेलेंट करते थे तो हम उसी को 8 grams कह देते हैं. Is that clear? So we are wanting to find, so when we are saying what is the equivalent mass of KMnO4, we are saying what is the grams in KMnO4 that reacts with 8 grams of oxygen. That's the question we are asking. तो एक तो हमने अपने फॉर्मूले से निकाल लिया. Now, just to make our understanding better, we are also calculating in terms of the ratios. So we say 5 O's are produced by 2, whatever the mass is of KMnO4. Let that be M. ठीक है? तो 16 होता है mass, atomic mass, oxygen का. तो 16 into 5 is produced by 2 into M of the KMnO4, right? So 1 will be produced, 1 gram of oxygen will be produced by 2M divided by 16 into 5. Is that clear? So 8 parts of oxygen will be produced when 2m into 8 upon 16 into 5. Clear? So that will also come out to be m by 5. So your answer will get verified, and you will also understand what one was trying to define or how one was trying to define the equivalent concept. Is it clear? Is it now clear to all of you? Now, this is the reaction of KMnO4 in basic medium. Right? This is the reaction of KMnO4 in basic medium. I'd like you to apply the same concept and find out the equivalent mass. You forget about all the other species. Just worry about how the Mn changes, right? And then how much oxygen is produced. And see that you are getting the same result or not. It's equal to molecular mass. By both the methods? Is it by both the methods? Have you been able to do it? Please take a couple of minutes more, but get the ideas clear. And now you can check the method here. Now, when you say that the medium is changing, how do you know that it's changing? मैंने बता दिया, I have told you, so you have agreed to it. How do you know that the medium is changing? Yeah, that is why. So you should know these things. Earlier it was acting with H2SO4, then it reacted with a base like KOH, now it's reacting with water. That's why this is a neutral medium, neutral reaction. Is that right? Now calculate it for this. And make one change in this. This is not 3 moles of water, this is only water. Balance करेंगे ना? तो stoichiometric coefficient नहीं आएगा. It is only H2O. Make that correction, please. Very good. Molecular mass by 3. Still some students are doing it. I'll give 1 more minute and then I'll go on. Is that clear? So now you've understood how to calculate equivalent mass in all the different cases. Redox, all the cases, non-redox, for acid, for base, for salt. Is it okay? This is my third case, which is M by 3. Fine. Now moving on to what are now the methods, the different stated methods to calculate equivalent. Now these are formulae. We could have really gone into the depth of each and every one, right? And figured out where they're coming from, but that would take too much time. So these are standard formulae that are there. And with each one, you can do a numerical directly to find out. So what the advantage of using these formulae are that they are the ready use ones. You have your data, you just plug the data into these formulae and you get the result, right? So for example, what is hydrogen displacement method? The mass of metal which displaces 11,200 ml of hydrogen at NTP from an acid, alkali or alcohol is the equivalent mass of the metal. Because we are talking of H, we are not talking of H2. If it's H2, it's 22.4, which is 22400. So H is 11,200. So that's where that factor of 11,200 is coming from. If your question has data given in terms of volume, you will use the second method. If it is given in terms of grams, you will use the first method. 1.008, as I told you, is only because you look at C12 as the reference. See, historically, we started with H. Then H was considered 1. The relative atomic mass table was constructed. It was first looked at from hydrogen point of view, where H was taken as 1. When it was taken as C12, hydrogen came out to 1.008. So you must understand where these numbers are coming from. Is it clear? Have you understood? Just write down a problem. Write down a problem based on this. 0.5 grams of a metal. I'll just a second. What I'll do is I'll pull that problem out. It will become easier for you. Yeah, this is the question. 0.1 gram of metal write down the problem so that we can go back to that page. Point 0.1 gram of metal gave on reaction with dilute acid at STP 34.2 ml. Why is STP important? Why? Why is it important? Yes, because volume of gases changes with temperature and pressure. Right. Have you noted the question? Okay, let's go back here. This was the method. So now it is hydrogen displaced or hydrogen produced, right? So it is 0.1 gram divided by 34.2, right? Into 11,200. Is that right? Do you understand? The question said 0.1 gram of metal. So weight of metal is 0.1. It gave 34.2 ml of hydrogen gas. So the denominator is 34.2 into 11,200. So what is the answer? What is the answer? 32 point, when you solve it, come out to be 32.7, right? Which is your first option of the multiple choice. Is it clear? So this is how we can very easily apply those and find out the answer. That's the utility. Is that clear? Now let's look at the next method. This is for oxidation formation or reduction of the oxide method, right? Now mass of the element which combines with 8 grams of oxygen is the equivalent mass of the element that we already know. So how do we calculate this? Equivalent mass of metal is mass of metal upon the volume of oxygen at STP in ml into 5600. Now I hope you can figure out what that 5600 is. I'll leave that problem to you. I want you to solve it. Till tomorrow morning, tell me where that figure is coming from. Right, right. But let everyone do it and then we can discuss it, right? Is it clear? So again, you can use the first option of the multiple choice. So what is the answer? Now here you can use the first equation only because it's masses. So it's mass upon of metal upon mass of oxygen combined into 8. Is that clear? Volumes are not into play, right? You can use directly the masses. So mass of metal is how much? It is 0.5 divided by weight of oxygen combined. How much is that? Into 8. So whatever that comes out to be. Have you understood the application? Right. So you will need to memorize these expressions along with all the methods. All the methods that I taught you up till now were all reasoning methods. So you don't need to memorize anything there. You can use your knowledge to solve it. These are shortcuts, right? A lot of times shortcuts are needed. So you can use these. These are directly ready-made equations and you can plug like you've plugged your data and find the answer. Is that okay? What does the answer come out roughly? 13 point something. So it will be 13.9 or something, roughly very close to 14. Clear? Next, chloride formation. The mass of element which combines with 35.5 grams of chlorine. So this is what we have done. There's nothing different except that if you convert it into volume ratio, then you have to automatically set your volume part right according to STP. right? So if you obviously if you're taking Cl2, then for Cl it will become 11,200. Clear? For the normal, it is mass of metal upon mass of chlorine into 35.5. Right? Now, please, this is mass of chlorine combined. Please mention that also. Mass of metal divided by mass of chlorine that is combining with the metal into 35.5. Have you understood? Again, I can use this in any which way. Okay, all the data when it's given, I can apply it. Now coming to metal displacement. So this is another way you can do it. 1 gram equivalent of more electropositive metal displaces 1 gram equivalent of less electropositive metal. Do you understand this idea? That's the concept of displacement reaction, which is based on reactivity series. So more reactive metal displaces a less reactive metal. So we say mass of metal added upon mass of metal displaced is equal to equivalent mass of the metal added upon the equivalent mass of the metal displaced. So from here you can find out one of the quantities because it's a ratio. Four variables are there. If three are known, the fourth can be calculated. So I can calculate the equivalent mass, or in many cases, I could also calculate the mass of metal added or mass of metal displaced. This will depend on the numerical, but that's the ratio. If you say mass of the metal added upon mass of the metal displaced, that happens in the ratios of their equivalent masses. That is what one is trying to say. Because everything is governed by stoichiometry. Is that idea clear? So for example, any displacement reaction, बताइए कोई भी displacement reaction बताइए. One of the easiest displacement reactions. Will this reaction take place? Will this reaction take place? Because Zn is above copper in the reactivity series. So it displaces copper, right? So this is what I'm saying. The metal, the mass of the metal zinc that is added upon mass of the metal copper that is displaced, not that is present, the one which is displaced, is equivalent to equivalent mass of equivalent weight of zinc upon the equivalent weight of copper. Clear? Is it clear? Now coming to the concept when you apply it to the electrochemistry. Now in electrochemistry, what is equivalent weight? It is the weight deposited by 1 Faraday charge. What is 1 Faraday? First tell me that. That we know. It is 96,500 coulombs. Where do we get this figure from? What is 1 Faraday? Tell me. Where? Yeah. Yeah. I still have about 10-15 minutes more. No? Right. Yeah, I'll find it up in 15 minutes or so. Yeah. Tell me. Yeah, it is the charge carried by 1 mole of electrons. So 1 mole of electrons is 6.023 into 10 to power 23. Please write that down. Into the charge on 1 electron, which is 1.6 into 10 to power minus 19 coulomb. Right? So this comes out, when you calculate this, you have 10 to power 23 and 10 to power minus 19. So that gives you a factor of 10 to power 4. Is that clear? 10 to power 23 and 10 to power 19, minus 19. It cancels out and you get 10 to power 4. You multiply the other factors that are present, which is 6.023 into 1.6. It comes out to be 9.648 roughly, right? You multiply it by 10 to power 4, it comes out to be 96364 or something like that, which is rounded off to give you 96500. That is how you get the figure of 96,500 coulombs. So 1 Faraday is the charge. Why do we call it 1 Faraday? Because it defines a unit of charge. Because it's the charge carried by 1 mole of electrons. Is that idea clear? Right? Now, that's the first idea that should be clear. Secondly, on passing the same amount of electricity through two different electrolytic solution, weight of X deposited upon weight of Y deposited is equal to the equivalent weight of X upon the equivalent weight of Y, right? Is that right? So again, when you have, for example, you were to take silver nitrate and copper sulfate. electrolytic solutions, and you would take them in beaker and put electrodes, right? You take a silver cell, silver nitrate, and you take copper sulfate. You take the two cells and put them in series. What is a series cell? Where the same current passes through both the cells, right? After a while, you will have silver deposited in its own cell on the electrode and copper deposited in the own cell. The ratio in which the deposition is taking place, the ratio of how much silver and how much copper, is a ratio of their equivalent weights. That is actually the Faraday's second law of electrolysis. This is Faraday's second law of electrolysis, right? Just write that down. When the same quantity of electricity, when the same quantity of electricity is passed through different through solutions of is passed through solutions of different electrolytes connected in series, weight of substance produced at the electrodes is directly proportional to its equivalent weight. Have you understood? So the same thing that you've written in terms of a ratio here is given in terms of words, right? So whenever you have two cells in series, whatever the weight is deposited in either of them is proportional to their equivalent weight ratios. That is what one is trying to say, right? Now just attempt a question not only on this, but just let's start with something simple. How much charge is needed? Just write down how much charge is needed to convert 1 mole of Cu2 positive to 1 mole of Cu. And 1 mole of MnO4 minus to 1 mole of Mn2 positive. I want the answer in Faradays. What's the answer for the first one? 2 Faraday. And the second one? 5 Faraday. Right? Now let's go on to the next question. Two cells containing solutions of silver nitrate and copper sulfate are connected in series. A current of 2.5 ampere was passed through the cells till 1.078 grams of silver was deposited. for how long did the current flow and what weight of copper will be deposited. Atomic mass of silver is 107.8 grams and of copper is 63.5 grams. Have you noted the question? Should I read it out? Yeah. Two cells containing solutions of silver nitrate and copper sulfate are connected in series. A current of 2.5 ampere was passed through the cells till 1.078 grams of silver was deposited. First part, for how long did the current flow? And second, what weight of copper will be deposited? Right? Atomic mass of silver is 107.8 and that of copper is 63.5. You have been told how much silver is getting deposited, right? Is that right? Please tell me, whenever something gets deposited, right? Is there a change in the oxidation number? No? What is getting deposited? What is getting silver? What is its oxidation number when it gets deposited as silver? 0. Right? Whenever something gets deposited, it gets deposited as in its pure form. Is it correct? In its pure form, its oxidation state is 0. Right? It is going from silver nitrate. What is its oxidation number then? Silver nitrate. Silver nitrate. What is the formula of silver nitrate? I've written it down. Nitric acid formula is? Yeah. Whenever you can't recall, you should look at what its combination with hydrogen is. So nitric acid is HNO3. Therefore, NO3 is -1. Therefore, silver nitrate, silver is +1. Is that right? So silver is going from +1 to 0. That means the number of electron changes 1. Ag plus is going to Ag. So there is 1 mole of electron change, right? That means 96500 coulombs would have deposited how much silver? How much silver would have 96500 coulomb deposited? When you say it is Ag plus going to Ag, we say this is 1 mole of electrons. 1 mole of electron is generating how much silver? 1 mole. No? Isn't it? 1 mole of silver ion is producing 1 mole of silver atom. Right? So this is 1 mole of electrons, which is 96500 coulombs, is generating how much? 1 mole of silver. So 1 mole of silver is how much? 107.8 grams. I've given the atomic mass of silver. Is that clear? Is that clear? So if 96500 coulomb was passed, I would have got 107.8 grams of silver. Is that right? But how much silver have I got? 1.078, right? So for getting 107.8 grams of silver, I would need 96,500 coulombs. So for 1.078, how much will I need? 965. Do you understand the relation? For 107.8 grams, I would need 96500 coulombs. So 1.078, for 1.078, how much will I need? 965 coulombs. Is that right? Is that correct? Right? Now, if we go on to whatever is relevant to us, which is the second part. The first part is not relevant, though it's not difficult, because you know I is equal to, you know, current charge Q is equal to I into T. So you have Q, you have I, you can find out T, right? But let's forget about that. Let's go to the second part. Now, what do we mean when you take two cells in series? It means that if in the first cell 965 coulomb charge has passed, it has also passed through the second. So here you have to reverse the argument. In the first case, you knew the amount deposited. From there, you calculated the coulombs. In the second, you know the coulombs, so you will find out the amount deposited. In the second cell, what do we have? Cu2 positive. Cu2 positive plus 2 electrons going to copper, right? That means 2 into 96500 coulombs will deposit 63.5. So how much will 965 deposit? Is it clear? And that is what you have done here in this formula. Weight of X by weight of Y, that's what you're doing. This is nothing but that. That's stoichiometry. Is it clear? Have you understood how do you apply this? Right? Is it clear? Let's go on to the next method, which is double displacement, double decomposition method. Now you know double decomposition is what? Or double displacement. The partners or the things are switched, right? So this is the formula you use for that. Weight of salt AB that is added to salt CD, that's given in the numerical, is divided by equivalent weight of radical A plus equivalent weight of radical D, because that are the ones which are combining in the product side, is equal to equivalent weight of radical A plus equivalent weight of radical B, which is your reactant, divided by equivalent weight of radical A plus equivalent weight of radical D. So that is how you calculate it. I'll have some more examples for that later on. Is that clear? So these are the examples that we have already calculated. So that basically summarizes the entire topic of equivalent weights, right? And how we calculate it. Is it clear? Have you all understood? Have you all understood the various methods? You will all have to digest it to be able to then start applying it, right? Now for tomorrow morning's class, what I'd like you to go over is the concept of equivalent weight or equivalent mass and gram equivalence, because we're going to begin with normality, right? So for that, I need you to not only revise how we calculate equivalent mass, but also the meaning of gram equivalent mass, and then taking it out to how to calculate the number of gram equivalent mass. So we will start with number of gram equivalent mass and then relate it to normality. Is it clear? So all the best. Thank you very much. Tell me. Electrolytic method because that was just the Faraday's method that I just explained. I'll just explain it again. Right? Electrolytic method is basically the weight deposited by 1 Faraday, which is, can I start? Yeah. It is the weight deposited by 1 Faraday of charge, which is 96,500. Where we're getting this 96,500 is, it is the charge carried by 1 mole of electrons. So whatever is the amount, for example, when we had calculated for, what were the two examples that I had given you? The first one was copper, was it? I'd given you two examples, MnO4 minus and Right. So if we want to calculate the equivalent weight of copper, right, what we do is, because Cu2 positive has got two positive charge, it needs two electrons to get converted into copper. And two electrons basically means 2 moles of electrons. Because if we are looking at a molar equation, it is 1 mole of copper reacting with 2 moles of electrons, giving you 1 mole of copper. So 2 moles of electron means 2 Faraday. Is that right? So what is the equivalent mass of copper? It is the mass which is deposited by 1 Faraday. Is that right? So if I was to pass 2 Faraday, I will get 63.5 grams. So by 1 Faraday, I will get 63.5 divided by 2, which is 31.75. So this becomes the equivalent weight of copper. Is it clear? Right? Thank you so much. Yeah. I will explain it tomorrow with an example. Yeah, I will explain it. That's why I left. That's it.
Hello, hello. Yeah. So when do I start? Okay, fine. Okay, students, good afternoon today. And we are in continuation with, in fact, last time uh, you were taught about laws of motion, right? And then in continuation, we took up some problems based on inclined plane and then, of course, pulleys. But we had put a condition that the bodies were moving smoothly, there was no friction, right? So today we are going to start with the topic of friction. Although in between a subtopic is left that is called conservation of momentum, right? Right. So you all know about what is momentum. I'll not take up this topic right away, right? Uh, I'll just give a hint that what do you mean by conservation of momentum. Then if time left, we might take up that because the friction topic is also quite involved, right? So we have to, in fact, not only start with friction, but try to do in the same lecture some problems based on frictional forces, right? So conservation of momentum, you know, what do you understand by conservation of momentum? Momentum is actually a vector quantity defined as if there is a particle of mass m moving with a velocity v, then momentum is, yeah, p is equal to mv, the product of the mass and the velocity. And in case you have two particles a and b which are moving with their own momentums PA and PB, then suppose that they collide with each other, then you know that whenever there is a collision, there is a exchange of momentum or there is a change in velocities, right? So suppose that after the collision, the particle A has a momentum PA dash and the particle B has a momentum PB dash, which changes. We are assuming that. Then the conservation law says that the two sums are equal, right? So the final momentum equals the initial momentum. So there is a proof for that, but we'll not take up right away. So we'll postpone for the time being. It's an important topic because you can solve so many problems using the law of conservation of momentum, right? But let me just give a hint because you might come across problems which you are solving from your book of Udaan or even CBSE or other books you are following. See, the law of conservation of momentum is not sufficient to solve a given problem, right? Like, see, in this problem only, suppose that you have two particles which are moving with some known initial velocities. Then after the collision, both the velocities will change. So you have two unknowns, but we have only one equation. So using one equation, you cannot find two unknowns. So there is another law called conservation of kinetic energy. So when you write an equation for conservation of kinetic energy, you get another equation. So two equations can be solved and then finally, okay. Now coming to the today's topic, friction, right? So friction is also not an unknown quantity or unknown uh, basically entity for you. You know that friction comes into play whenever we do something or whenever there is a motion, right? See, for example, suppose I set a ball rolling on the floor. You know that after some time, the ball stops. Why the ball stops? Because between the ball and the ground, there is a friction. Or a car is moving, right? But as soon as it applies brakes, it doesn't stop, but it keeps on moving. But after some time, it also stops. Why does it stop? It is due to friction, right? And this friction is basically a force. Whenever, see, basically, according to Newton's second law, whenever we want to give a motion to any given body, we have to apply a force, right? So if the body does not move, so that means there is some other force which is not letting it move. So that is called frictional force. So friction is basically a force called frictional force, right? So suppose that you have a body M, right? And I apply some force on it, right? Then it is found that the frictional forces between the two surfaces which are coming in contact. It is sometimes due to the contact of the two surfaces, right? So the frictional force is always in a direction opposite to the applied force or to the direction in which you want to produce motion, right? And this force always opposes the applied force. So initially it is found that experimentally that on a static body, if you apply some amount of force, right? Now, according to Newton's second law, whenever you apply force on any given body, it should accelerate the body. And the acceleration will be given by A is equal to F upon M. But here what is happening, that there is a body of mass M, we just apply a small amount of force, the body does not move. So that means there is some equal amount of force which is opposing it. Now suppose that we increase the force, then also the body does not move. That means initially when we applied small force, there was a small force which was opposing, right? The force, I mean, this is an important point to understand, that the opposing force has to be equivalent amount with the applied force, because otherwise if the two forces are not equal, there will be a balanced force or a net force and the body should move. Since the body is not moving, so that means if you write F and F, as you are increasing F small f is also increasing, right? And that force is basically frictional force, right? Of course, uh, we there have been research to find out why there is a frictional force, and the cause has been found that normally, see, whenever you feel, see, for example, suppose that you look at the surface of this table, it looks to be quite polished, right? So you feel that it is very smooth and anything put here will smoothly roll, but it is not, because if you microscopically see any surface, you find that there are irregularities on the surface, and when you keep another body, there are irregularities there also, and because of the two irregularities, there is a hampering of the motion. So in fact, we'll in fact talk very briefly, because there is only one lecture for friction and the problems based on friction. So you understand this concept, that there are irregularities on the surface on which the other body has to move. So because of the irregularities, there is a, see, previously it was thought that there is a interlocking in the sense that, as if you know, physically or mechanically also, if you interlock two things, they don't move, right? But it is not actually the cause. The cause is due to electromagnetic forces. You know that in nature there are so many types of forces, right? One important force which we have been working with, which we have learned already, is gravitational force. But then you know that there are forces called electromagnetic forces. So we'll not go into detail, but why? But you know that electromagnetic forces are due to charges, right? So unlike gravitational forces, there are two kinds of charges which can be attractive or repulsive. So normally, because of the electromagnetic forces between the two surfaces, they are called intermolecular forces. You might have learned about Hooke's law also before. Anyway, for this is enough to understand that there are electromagnetic forces which don't allow the two surfaces to move with respect to each other, right? And you have to apply enough force to uh, make the motion, right? So basically what is going to happen is that as you keep on applying force, the opposing force also keeps on increasing, right? But then you know that eventually things are like, I mean, suppose that a small child likes to move some heavy body, he will not be able to do it, he or she will not be able to do it. But if the force amount is increased, eventually the body will move, right? So there is a limiting value, there is a value called limiting force, right? After which eventually the body will start moving, right? But when the body starts moving, then it is found that you need a slightly lesser amount of force to move the body, right? And after that, the frictional force becomes constant, right? And you have two kinds of forces: static friction, yeah, kinetic or dynamic friction. So up to the limit you have reached, till the limiting force is applied, the frictional forces are increasing with the applied forces and the body does not move. But as soon as the limiting force is comes after that. When you increase the external force overcomes the frictional force, and the net force applied on the body imparts it a acceleration or gives it a motion, right? And the relation between the two is, sometimes you write, since Fs is proportional to F, so you write Fs is equal to mu s into F, right? So the relation between frictional force and the applied force is, so this is called constant of proportionality, which is called constant of friction, static, constant of static friction. So similarly, you define something called coefficient of kinetic friction, because the force applied, okay, so you can write F k is equal to mu k into F. So there are two constants, mu s and mu k. Normally, they are different in values. Mu k is slightly lesser, and mu s has a higher value. Like, I mean, if one has value 0.5, the other could be 0.4 or 0.45. But normally, in certain problems, as we'll see later on, if sometimes only one frictional constant is given, so we assume the same value for both, right? So depend. Otherwise, sometimes the two values are given separately, also depending upon the problem, right? So these two equations will be important for us in future. So in a way, if there is a block of mass m, see for example, then how many forces in general could be acting on that? As before, the weight of the body, mg, right? Reaction, which is normal, which is in this particular case equal to mg, because it is equal and opposite to the weight of the body, and then some applied force, which you could say F, and then the frictional force. So depending upon the amount of forces, the body will either move or not move, right? So should we go ahead with some numericals from here only, because it looks like that some of the fundamentals are known to you, because being students of 11, you have already advanced in your basic course also, so might have studied few things before. It's not just beginning of the course here. So I'll assume some knowledge, but wherever if you think that I'm saying something which is out of your scope or you have not studied before, you can ask me, right? You can always tell me. Okay, so now suppose that we take a, okay, then some characteristics or properties of limiting force, right? So I think the textbook material I might not take, like you say that the force, frictional force does not depend upon the area of contact, right? If the normal, because one can see that from the relation. So the amount of frictional force depends upon the normal force acting on the body, right? So as far as the normal force remains same, the area of contact will not matter, right? Because Fk depends upon, is proportional to n, right? And then of course it depends upon the nature of surfaces, right? So you know that if the surfaces are polished or oily, or if they are rough, so in every case frictional force is different from each case, right? So it increases with the roughness and it decreases with the polishing or smoothness, right? So all these things are known. Now suppose that we take up a problem as an example. Okay, so suppose that there is a block of mass 2 kg lying on a horizontal surface, right? And suppose a force, and suppose that the coefficient of friction, the static coefficient of friction between the surface, the bottom surface of the block and the ground, or the, like suppose it is kept on a table, then the upper surface of the table is 0.5 and the kinetic coefficient of friction is 0.4, right? Now suppose that a force of 5 Newton is applied. Suppose an external force is applied to move the block horizontally, right? So the force is applied horizontally, And so I've shown the direction of F. Now we have to see that what happens, right? Now, you know that in order to solve any problem in dynamics, you always, or statics, you always make a free body diagram. But first we identify all the forces acting on the body, right? So this is the external force we are applying, but already the weight of the body, how much? 20 Newton. 20 Newton is acting vertically down. And because of that, a normal force of 20 Newton is acting vertically up, right? And both are equal because there is no vertical motion, right? And since we are trying to move the body rightwards, so there is a frictional force acting leftwards, right? You need not draw arrows because we are only worried about the magnitude of the forces. So F, right? Now initially the body is not moving, so the static friction will have to be considered. And the static friction, as we know, is given by Fs is equal to mu s into n, right? Now we find that n is 20 Newton and mu s is given to be 0.5. So Fs will become 0.5 into 5 Newton into 10, 20 Newton is equal to 10 Newton. So already because of the weight of the body, a frictional force, static frictional force of 10 Newton will act between the two surfaces. And we are applying only 5 Newton force, which will not be able to overcome the friction. So there will be no motion, right? Now the second case is just to have a feel that how does friction change the dynamics of the problem. Initially, see, if we had not studied about friction or if you were ignoring friction, then as soon as you apply 5 Newton, the body will start moving, right? And with how much acceleration? It will be given through the relation A is equal to 5 Newton upon 2 kg, 2.5 meter per second square immediately. But here we find that body will not move at all. Now suppose that we take a case that F is equal to 15 Newton, right? Suppose now a 50 Newton force is exerted on the body to move it horizontally rightwards, right? Then in this case, we find that F is 50 Newton and this is greater than Fs. So this is greater than Fs, right? Five Newton. So there will be some net force acting rightwards. So which can give or impart acceleration to the given mass, right? How to calculate that? So how will you find the net force? It will be 15 Newton F minus what? Not Fs, but Fk. This is important point. Fk. Why? Because once the body starts moving, then the kinetic friction will come into play. And we have to calculate Fk separately, where the equation will be given by Ma is equal to, according to Newton's second law, Ma is equal to the net force acting on the body. So F minus Fk, where Fk is equal to mu k into n, or equal to 0.4 into 20, or equal to 8 Newton. 8 Newton. So equation will become Ma is equal to 20 minus 8 Newton equal to 12 Newton, or A is equal to 12 Newton upon 2 kg is equal to 6 meter per second. So the point to note is that when the body starts moving, then you have to worry about kinetic friction. Then you will not take F. But before the body was moving, right? Now, see, look at here. We can take up an example. One can see that when the block is set into motion, then a kinetic friction of 8 Newton is always to be overcome. Whatever external force you apply, it has to be greater than 8 Newton. But to begin with, had you applied, take another example, had you applied 9 Newton force, what would have happened? Suppose initially the body was at rest and we applied a force of 9 Newton. What would happen? It will not move. It will not move because the static friction of 10 Newton is still acting on the body. which will not allow it to move. Only because there is a limiting case. Oh, that diagram I have removed, right? So the frictional force keeps on rising with the external force. But once the motion is set, then the frictional force becomes slightly lesser, right? So in that case, the force for calculating the final acceleration, here you have to take Fk. But to see whether the frictional force will allow the body to move or not, you have to take consideration static force, right? So under 9 Newton, it might not move. Now, few more things to define actually. Angle of friction and contact force, right? In the contact force, right? How do you define the two? Again, the same diagram, right? Now one can see that even if you don't apply any external force when a body is lying on a surface, three forces are acting on it. Of course, a weight due to the gravitational force, but because of that, there is a normal force, which is actually a reaction force and the static friction. So in a way, two forces act on the body, the normal force and the frictional force, right? Now we say that if you take the resultant of the two, right, since there are two forces, both are acting perpendicular, the resultant will be easy to evaluate. It will be along the diagonal of the rectangle, right? Then this angle, which is formed between the normal and the total reaction, total force acting, is called angle of friction. Is called angle of friction, right? And how can you find angle of friction? Look at here, there is a right angle triangle. Then in the right angle triangle, this is F, this is F. So F upon N is equal to tangent phi, right? And what is F upon N? We know that F is mu N, right? I'll sometimes use the letter only mu for the coefficient of friction, because we know that only when the body is moving, then only the friction is to be considered to, numerically solve some problem. So mu will be always kinetic mu only. So here, this is equal to mu n upon n or equal to mu. So we have a relation mu is equal to tangent phi, or phi is equal to tan inverse mu, right? So the angle of contact can be found from the coefficient of friction of the given body with a given surface, and this relation we have, right? And the total contact force, how will you find? R, and magnitude of R will be root of F square plus mg square, right? So we can write this way, right? So this is the total force, the magnitude of the force R acting on the body, right? So should I remove it? Okay, thank you. Now, normally, while solving a class of problems which we have taken before also, we don't always take bodies moving on a horizontal surface, because in normal life also, we many times move on an inclined plane. So we always take an inclined plane, and a block of mass kept on the along the incline. And whenever you talk about incline, we do talk about the angle of the incline, right? So it could be steep, it could be very small wedge, right? But your before, I mean, the knowledge you have gained earlier before actually we started learning about friction. If there had been no friction in such a situation, what will happen? What will happen to the block? It will slide, right? It will slide because there is going to be a net force acting. Why? Because if the mass is, yeah, you're right. So one can resolve and, okay, let's see. This is mg cos theta, mg sin theta, right? Mg sin theta. And of course, normal is normal to the surface. So normal, that's why the name is normal. It is normal to the surface of contact, right? So in this particular case, it is not mg as before, it is mg cos theta, right? But now we know that frictional forces are there. So as soon as you have here, and since the block likes to move downwards, the frictional force is going to act upward, right? And how much is the frictional force? Frictional force is mu n, right? Yes, I can. And in this particular case, it will be mu into mg cos theta. So this much amount of force is going to stop the block from slipping or sliding. And what is the force which is trying to pull it downwards? That is mg sin theta. So mg sin theta likes to take the block downwards, whereas the mu mg cos theta force tries to block it, right? Stop that movement downwards, right? So depending upon the relative values, the block will either move or not move, right? So in case mg sin theta is less than mu mg cos theta, the block will not move, right? Now it depends upon the angle. It's obvious here. It all depends upon the angle theta, right? Because this relation, because for some particular, in fact, one can calculate for some particular value of theta, this quantity and this quantity might be equal. So in that case, the force on the block will be, the force along the incline on the block will be zero. And as soon as one force will overtake, it will start moving, because Newton's second law says that as soon as there is a force acting on a body, it should move with certain acceleration, right? So that particular angle, theta is equal to alpha, is called angle of repose. So this is a definition for the angle of repose for an incline. That angle of the incline where when the angle is slightly greater than that, now this is obvious, if the angle theta is less, there is a less chance of sliding, but as you increase theta steeper, then there is more chance. So this is the minimum value of theta. And how do you calculate that? By equating the two, right? mg sin theta is equal to mu mg cos theta, or m cancels out. We can take cos theta on the other side to get a relation. Tangent theta is equal to mu sin theta upon cos theta. M cancel, g also cancels out, or theta is equal to tan inverse mu, right? So the angle of repose can be calculated from the given value of the coefficient of friction on the between the block and the surface of the incline. So if the angle theta, the angle is more than theta, there is a likelihood that the body will slide down, right? Now suppose that we take a, okay, is it clear? Alpha, actually I should have written, क्योंकि हमने इसको particular name दे दिया है ना. Sorry, you can make changes in your notes. So instead of theta, because theta is a general notation for the angle, and where we are saying that let theta be alpha, which is called angle of repose. This is how one can find that angle, right? Now suppose that we take a case where theta is greater than alpha. Suppose that incline makes an angle theta which is greater than the angle of repose. right? So in that case, what will happen? The downward force will be greater than the frictional force trying to stop it. So in this case, we can calculate, find the acceleration in this particular case. So the net force according to Newton's second law, ma will be equal to mg sine theta minus mu mg cos theta, right? Or a is equal to m cancels out everywhere, g is also common into sine theta minus mu cos theta. So one can find the amount of acceleration with which the block will come downwards when the angle is more than angle of repose and a net force acts downwards, right? Okay, rolling friction, should I need to explain? You have the idea, like when a car is moving on the road, then the wheels are circular, right? Unlike compare the two. When you have a block which is cubical in shape, then the area of contact is much more as compared to the case when a wheel is moving or a ball is rolled on the road. So the area of contact is less. So as I told you that frictional force is because of the irregularities between the two surfaces. And let's say roughly as we try to understand, there is an interlocking, so which tries to oppose the motion. So in this case, since the surface area of contact is too small, so the friction is going to small, right? But then it is not so simple. It's not so simple that, of course, it is smaller. The rolling friction is much smaller than, this is called rolling friction, which is much less than the sliding friction, right? Or the kinetic friction, of course, both are kinetic frictions. So which is less than the, but the what actually happens is that, see basically what is happening, suppose a car is moving. Now car has a mass, great mass, right? Now you know a quantity called pressure, right? What is pressure? Force per unit area. Now obviously in case area of contact is less, pressure is going to be enormous, right? So because of that pressure, you might have seen in moving cars or even cycles that the tire becomes slightly flatter, right? Because the pressure is so high, it deforms not only the bottom of the wheel but also the surface or the road on which it is moving. So the road conditions are important, right? So both are deformed, and sometimes to show the diagram of this kind, so as one can see that the tire is in a large contact with the road and there is a depression because naturally because of the weight, right, or the downward force, the, and as we have understood that there is a deformation and there is a enormous pressure, so the road goes, beneath its own original shape, and in a way the tire moves inside. So that's why, because otherwise if this thing doesn't happen, then the rolling fraction is going to be just negligible, no value. But because the tire at every movement, because at the next movement when it reaches here, the same thing will happen. So as if the car is always trying to pull it outside the depression formed on the road, right? So that's why there is some value of the rolling friction. Okay. Right. Let us take another example where we try to see that how does friction, again, see, so far what we have done is we have taken problems where we were concerning only with one mass and one surface and then the movement. Now let's suppose that we take a composite problem, take another example, and let's suppose that there is a surface on which two masses are lying. Let's say one is 4 kg and another is 2 kg, right? So there is one block lying on the ground, and on the surface of the block there is another block which is, let's say, smaller and has a mass of 2 kg, right? We could have taken problem as m1 m2, right, and solved in general, but when you take numeric values it becomes more important, because then you can actually see what is going to happen, because otherwise you'll have to always give inequalities. This will happen, then this is going to be okay. Now suppose that we apply a force on the upper block. The force F is applied on the block which is lying over the other block, right? Now before that we should know certain few more things in the block, in the problem, that now see, there are two surfaces of contact. The lower block is lying on one surface, could be ground, and the upper block is lying on the lower block, right? So one must know about the friction between the, so friction here and the friction here, right? Now suppose that we assume that there is a friction between the two blocks. There is a frictional force present between the two blocks, but between the lower block and the ground it is smooth. The lower surface on which the 4 kg block is lying is smooth, right? So it can move easily. But between the two blocks there is a friction, right? And let's see, in the given problem the values are given. Okay. Now suppose that we apply a variable force on the upper mass. Let's say the force is given by F is equal to 2t, right? F is equal to 2t means it's a force, t is time. So it's a force which is increasing with time, right? So after 1 second, and the force is in newtons. So that means the force in the beginning, when t is equal to 0, the time just starts, the force is 0. But as the time progresses, the force increases. Like what you could have done is you tie a rope here, and the other end of the rope is connected to the rear of a car, and the car starts moving. So as the car will accelerate, with time the acceleration will increase and the force applied on the two blocks will increase, right? So let's suppose that the force increases linearly with time. So it is given by 2t, right? So we have to see that what actually happens in this particular case, right? What will happen? Okay, what do you think will happen? As soon as you apply a force on this pair of two blocks lying on each other, and the whole pair lying on another surface, and a force applied horizontally, right? Of course, the force is a variable force, which is given by 2t, but the main thing is a force is applied. So what is going to happen? What do you expect to start with? Will not move. Okay. Anybody else? Just to repeat, there is a friction between the upper block and the lower block. That means the contact area between the two blocks, but between the lower block and the surface on which the heavier block is lying or is placed, it is smooth, it is frictionless. So this surface is smooth, means could have said frictionless. So this surface is frictionless. So what will happen? Both the blocks should move, right? Because the lower surface has no friction and you are applying, but why should we think that both the blocks will move? See, we are applying the force on the upper block. Please note that point also, right? But sometimes see, physics basically comes from your common sense also. So common sense says that although you are applying the force on the upper block, but since between the upper block and the lower block there is a friction, and unless the friction is overcome, the upper block will not move with respect to the lower block. So initially we have to make an assumption that suppose that the friction is between the two blocks is high and the initial force is less, and the upper block does not move above the lower block. So that means it becomes a composite body, right? The two becomes joint, right? So two, as if both the masses are acting as a single mass, right? And the lower mass, since it is lying on a smooth surface, can move. So both the blocks can move. So both the blocks can move, right? Okay, before actually we solve the problem, let's make suppose we could have called this block as A and this B. So we can make a free body diagram for both, right? So for when we make a free body diagram for both, so for A, when we make the free body diagram, suppose this is your 2 kg mass. Now what are the different forces acting on it, right? The different forces are normal, right? And weight, force applied, and the frictional force, right? So the rightward force which you are applying externally, leftward force because there is a because you want a movement on the right hand side, so frictional force opposing that leftwards, and normal and the weight, right? Continue, right? And for the second body, here, what are the different forces? 40 Newton, and then there is no friction. There is no friction between the lower body and the lower surface. So there is no frictional force. There is no external force also, since that is applied on the upper body, right? But then, no, there is no frictional force on the lower surface of the lower block. But what about the upper surface? Right? There will be a frictional force, right? Which will be this way. See, when you consider these two blocks, right? You are trying to move this block rightwards. So a frictional force developed which tried to take it, which tried to oppose the motion, and that acted leftwards, right? Or I mean, one could have considered a direction. If the force is in the plus x direction, the frictional force is in the minus x direction. But because of Newton's third law, an equal amount of force will apply on the upper surface of the lower block, and it will be opposite to the upper force, right? Look at here. At this contact, on this a force F is acting, and on this a force F will act on this direction. And because of this only the lower block is moving. Look at here, because see, we are externally not applying any force on the lower block, but since it is moving along with the upper block, so it is moving due to friction. The block B moves because of the friction between the two blocks. So it moves only because of the friction between two blocks, right? Okay, the frictional constant might have been given. I'll just see. Yeah, half. So value of mu is given, is to be half, right? Okay, we were drawing the free body diagram of the block B. What are the other forces acting? Hmm? Hmm? And B, right? The reaction on the second block, just like other cases, right? So the normal force acting on the other block, and what else? Hmm? And NB. NB also acting downwards, right? Because on the On the second block, because of the first block, there is a normal upwards. So on the second block, there is a force downwards also, right? Why it has to be there? See, you think logically. See, as far as the upper block is concerned, it has a weight of 2 kg or 20 Newton. So it is lying above. So the the gravity pulls it down with a force of 20 newtons. But the lower block on which the upper block is also lying, how much force will be downward? 40 plus, this is equal to, no, and I should have written NA, NA, the upper block, right? And how much is NA? 20 Newton. 20 Newton, right? Okay, now see, just I told you that the lower block on which no external force is being applied directly still moves along with the first block initially. And why does it move? Because of the force F shown in the free body diagram of the second block, right? We can calculate that. How much is F? We can calculate F. How will you calculate F? Mu n, right? So how much is that? One by 2 into 20 Newton is equal to 10, because frictional forces between the upper block and at the surface between upper block and lower block, right? And there the normal is 20 Newton, and the frictional force coefficient of frictional force between the two surfaces is given to be mu is equal to half, right? So this is here equal to mu is equal to F is equal to mu n is equal to 10 Newton, right? Yes. See, basically, there is no friction here. If there had been a friction here, then you would have considered normal due to both the blocks, because the whole, see, basically, why in fact you could have asked few questions in between, why the friction depends upon the normal. See, basically, suppose this is a block, right? And normal is always applied normally. We'll take up that example also later on. So if normal is more, the body is less, it is more difficult to move the body. If the normal is less, it is easier. So this normal force is important. What is a normal force, right? So here at this surface, the normal force is only due to the upper body, not due to the lower body. Lower body is exerting a force on the lower surface. So when you are considering in that surface, we have already taken to be smooth, frictionless. That's why the whole thing was moving, right? We could have taken another example where that was also there. But anyway, in the simpler case, so there is only the force of friction present here. Force of friction present here, right? Now, see, basically what is happening? This force which is externally applied on the upper block, right, is an increasing force. It is not constant. It is increasing with respect to time, right? Now, and there is a friction between this force, this block and this block, right? Now, so far as the friction is there and this applied force is lesser, right, the upper block is not slipping. It is in contact because of the friction. The two blocks remain as a single piece. They are not moving with respect to each other. They move as a total single unit. But as soon as capital F, the external force, is going to become more than small f, what will happen? That means in that case, the external force when f becomes greater than f, right? When I speak f, it could be capital, depends. I mean, you know what I'm referring to. So need not say capital F or small f. So when capital F, which is the external force, becomes greater than the frictional force, what will happen? Then in that case, since there is no force you are applying on the second block, the first force will, so the upper block will start slipping. Then there will not be a joint motion. Then the upper block, which was not moving with respect to the second block, because the frictional force was greater than F, right? And why the whole system was moving? Because the total, since it was not moving with respect to each other, then they were acting as a single unit, and the lower surface was smooth, so the whole thing was moving, right? Whole thing was moving. But as soon as F will become greater than small f, frictional force will become lesser and external force will become more. Then the upper block will start moving, and the lower block at that time will stop moving. Whatever motion it has, it will keep with that, but after that it will stop. With respect, I mean, with respect to the upper block, it will not move, right? In fact, we what we are interested in to see that how, I mean, before capital, since it's a function of time, so we want to study everything as a function of time. पहले तो ये हम ड्रॉ कर लेते हैं ना, this is t, this is your f which you are applied. So this is the external force you are applying, which is linearly increasing with time. Now we want to study the motion of the two blocks, that also with respect to time, right? So we want to see with respect to time. Motion means acceleration. So suppose that for the block A, the acceleration is called AA, and for the other block it is called AB. So on the same graph we will plot two quantities, acceleration of the block A as well as acceleration of the block B, right? Now obviously when the external force is less than the frictional force, both the things are moving together as a single piece. So in that case AA and AB will be same because both have the same acceleration, right? We will calculate that, right? But we first find that as soon as F will become 10 Newton. Now before F becomes 10 Newton, where is the second body getting its motion? Due to the external force, right? And what is its upper limit of the acceleration? What will be the upper limit of the acceleration? Applied force upon its mass, 4 kg. So no, yeah, 10 Newton. So the lower block will initially both are at rest. So as they start moving, their accelerations increase because when you apply forces on any body, the acceleration, and of course in this case a force is a time dependent force. So with time, force is increasing, so the accelerations will also increase. They are both functions of time. And from this equation we find that as soon as the acceleration will reach a value of 2.5, that is the stage when the external force is going to be equal to frictional force. So this is the maximum value of the acceleration of the lower block. After that it's not going to attain any acceleration, right? So it will be this way. And after how much time that will happen? After how much time that will happen? Okay, first let's see how much, what is the acceleration of the system? What is the acceleration of the system? F upon ma plus mb, right? Acceleration of the system is ma plus mb. And f is 2t, right? But only after f becomes 10 Newton. Till f becomes 10 Newton, both the blocks are moving together. That's why we are dividing by ma plus mb. And this is the upper limit of the force. So upper limit of the total acceleration is 10 Newton divided by 2 plus 4. 10.6 and how much? 1.66. 1.66, right? No. And this acceleration was how much? 2.5. So how to calculate that? 2.5. No, there is something wrong, no? we can actually calculate time, right? We can actually calculate time at which the acceleration of the system becomes 2.5 meter per second square. And as soon as the acceleration of the system becomes, that will happen after 7.5 seconds. 7.5 seconds. Is this point clear? Right? See, to understand again, the force is initially starts from 0 and keeps on increasing. And initially the frictional force is more than the external force. So both the blocks move together. And their acceleration will be, of course, given by F upon ma plus mb. Right? That is the formula we have used, F upon ma plus mb. Now, the lower block is moving because of the frictional force. And as soon as the external force will become greater than F, right, then only the upper block will move, because the two were joined because the friction was stopping the upper block to slip, right, horizontally. So the upper limit of the force which is acting on the lower body is given by the frictional force. So F is equal to mu n given by 10 Newton, and because of that 10 Newton, it should attain an acceleration of 2.5 meters per second square. So this is 2.5 meters per second square, and this is both AA and AB, right? And after that, this is AA and this is AB. Why AB becomes more? Because now the force acts only on the upper body, right? Upper body, which was receiving the external force, has now started moving on the surface of the lower body. And how much is its acceleration? Its acceleration is given by F upon only ma, right? And one can see this point. This is a point at equal to 7.5, right? And after that, the force, because of the force, the lower block does not move now along with the upper block, and upper block moves faster because it receives the whole force, right? So this is how frictional forces can change the whole picture, right? Now a similar problem. Okay, we'll take up a similar problem. Should I remove this? You want to know? Okay. A similar problem is, there is a horizontal plane surface on which two blocks are lying. Named as block B and block C, right? If I remember it correctly. So there are two blocks lying on a horizontal surface, the block B lying on the surface. Above that, another block named as C, right? And a rope is connected to C, which goes along a pulley, and to the other end of the pulley, another mass or another block A is connected, right? Now, as before, we assume that between the blocks B and C, there is a friction, right? Frictional constant we could have written as mu. There is a friction between the block B and block C, but the lower surface is smooth. The surface on which block C is lying is frictionless, right? Is frictionless. Hmm? No. Surface between B and C as before is not frictionless. वहाँ मैंने mu show किया है ना, वहाँ पे friction है with a friction cost जो जिस पे C lie कर रहा है. The surface on which the whole system is lying, the two blocks are lying, that is smooth. Otherwise, there will not be motion, or there will be Okay, to begin, and then the mass C is connected to a rope. The rope goes along a pulley, and vertically when the pulley goes down, another block A is connected, right? So there are two parts in the system, horizontal as well as vertical. We are not, unlike the previous case where we were applying force to move the bodies, here the force is because of the gravitation, right? Okay, to start with, what do you expect will happen? This girl, अगर ऐसा सिस्टम बनाएंगे when we are having three blocks, two lying on each other on a horizontal surface and the third one vertically down, and there is a single rope connecting C and A, what is going to happen? If the system starts from rest and you leave it free, what will happen? It will pull it down, right? The force, gravitational force, right? Since a force, because of the weight of the mass A, mass of the block A force of mag will act vertically down, right? And pulley is also assumed to be frictionless, so the rope should go down, right? So the system will have some acceleration. Why it should have acceleration to start with only? To start with only the system will have acceleration, or will the system have acceleration to start with only, or depending upon the relative masses, or as soon as you leave the system free, the system will start moving? Let me repeat the problem. There is a friction between the at the area of contact between B and C. There is no friction at the bottom of B. There is no friction between the bottom of B and the lower surface. So will it still depend upon the masses, or see the lower surface is smooth, system will immediately start moving. As soon as this mass, because of the gravity, goes down, because of this rope, it pulls the whole system horizontally. So there is a vertical motion for the mass m, and there has to be a, I mean, we expect a motion along the horizontal surface where the two blocks B and C will move together. Now we have to judge actually whether that motion will occur immediately or after certain time, or depending upon the relative masses. See, it will happen immediately because the lower surface of B is smooth, and because of the friction between B and C, the C will not move with respect to B. It could move there, it will matter how much are the masses, right? Because there is a friction between B and C. If the force, downward force, which is pulling C horizontally is more than that frictional force, then C could slide above B. But in case that force is, there is a force, but if this is lesser than the frictional force between B and C, then B and C will, as before in the previous problem, B and C will act as a single block, right? They will be joined because of the friction. C will not be able to move relative to B. And since B is able to move on its own surface, so the whole thing will move. The whole thing will move, right? Now we can draw the free body diagrams, right? So to draw the free body diagram of B, let's say first, or let's say C first. So the mass is mb. So because of the weight of the body, a downward force mb g, oh, c लिया है, in the normal nc, right? And along with T, tension in the rope. Remember, the tension is always right? Tension is always this way, right? Away from the point of join. Hmm? So what is the time? Last week's pending question that I, because I thought today also there will be questions, so we can solve them, and can we load on some website or somewhere? Mm-hmm. Okay. And free body diagram of A and B. Okay, when you take the free body diagram of A, then MA, G, T, right? There's the frictional force, right? एक्चुअली उसमें मैंने पार्टली से सॉल्व किए हैं, पर एक्चुअली हुआ क्या कि मुझे बीच में शर्मा जी ने कह दिया कि पहले का सारा छोड़ दो। मैंने तो लॉ कंजर्वेशन मोमेंटम भी करना था और इम्पल्स था और सर, तो उन्होंने मुझे फ़ोन पे कहा कि एक्चुअली आप लोगों ने क्या किया, 2 लेक्चर का कंबाइन कर दिया। एक तो मेरा प्रीपोन हो गया, एक उन्होंने कहा फ्रिक्शन से स्टार्ट करना, पहले वाला नहीं करना। ओके फाइन, सो आई हैड टू स्टार्ट फ्रॉम, so it is basically both lectures. No, that's okay. Let me first finish this problem. Yeah, let me first. Yeah, yeah. No, if you are not comfortable, please let us know. So okay. We will put another solution. Okay, fine, 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 fine. So to finish the whole topic, because we might need another lecture to take up the pending problems and problems arising here also. It cannot be taken. Now see, in such problems, it is always a good idea to understand because constant relations are there, right? Because there are two masses and there are in fact three masses, two are joined, and because of the friction, both are unable to move with respect to each other, right? But see, look at the diagrams I have shown. When you draw the free body diagram of B and C separately, you have to show frictional forces, right? But initially, when the friction is not allowing the block B to slide or slip over the actually I've drawn the blocks B and C instead of C and B anyway. So I have to see the diagram. So because of the frictional force, C is not sliding over B. So in a way, the whole unit is moving as a single piece, as a single unit, right? So we can, since B and C as a joint are moving together, so there is no need to draw the free body diagram of B and C separately. You need to draw the free body diagram of B and C separately, because if B has a separate motion and C has a separate motion, if you show the free body diagram of B and C together, then the whole system is moving with the acceleration A, right? And how much is the mass? mB plus mc. And what is this? Being, this is the tension in the rope, right? Because the tension is pulling, tension in the rope is pulling the whole unit, and the whole unit has a mass of mb plus mc and moving with the acceleration a. So see, if you look at mb plus mc together, see when you draw the free body diagram, and as I said in the in the last lecture only, because I've taken only one lecture before. See, when you draw the free body diagram, then you resolve the different component. You always use a coordinate system and resolve all the forces in components along the axis of the coordinate system. So here, since we are working over a plane, there is a vertical axis, there is a horizontal axis. So you'll have to balance horizontal forces and you will have to balance vertical forces. There is no need to write equations for balancing vertical forces because there is no vertical motion, although they will balance and one can find some relations. But since the block B and C both are moving horizontally, so I am writing only the horizontal equation. So MB plus MC will be equal to A. And here MA, and here we have to write the equation for the vertical direction. Look at here, the block A has a downward mass MAG and tension in the rope is T. It is T. So the net force is MAG minus T downwards, and downwards it is suppose moving with the acceleration A. Here also I have taken A because the whole system is moving with the same acceleration A. There is a single rope tying C and A. So as C8 goes downwards, C is pulled horizontally, right? So here also acceleration A and here also acceleration A. So you have two equations. Now if we add the two equations, adding 1 and 2, what will happen? This could have been written as T is equal to MB plus MC into A. So MAG minus T plus T, right? And on the right hand side, MB plus MC into A and MA into A. So you get a equation MAG is equal to MA plus MB plus MC into A, or first let's write MA plus MB plus MC into A is equal to MA into G, or A is equal to MA into G, divided by MA plus MB plus MC. Fine. Now look at here. This relation we could have written directly also. It is so simple to understand, but it is not a good idea to write directly. You can always write force equations for each part of the system. There are three parts of the system, but two parts are joined. So we have taken them as one part. So the total downward force is Ma into G because the mass Ma is going downwards. So the total force on in the system is Ma into G. And how many masses are moving? All the three. So it is to be divided by, so final acceleration is Ma into G divided by Ma plus Mb plus Mc. So that will give you the total acceleration. Now let us see what is desired in the question. Find the distance moved by the block C when the block A moves by a distance of 2 meters. Okay, the problem is also given. Ma is equal to 4 kg, Mb is equal to 10 kg, and Mc is equal to, let's say, 6 kg. Then A is equal to Ma into G. Ma is 4 into 10 divided by 4 plus 6 plus 10. Ma plus Mb plus Mg. 2 meters per second square. 60 Newton, right? One can calculate the tension also. How much is the tension? T one can, okay, we can make various calculations. T is Mb plus Mc into A. A we have already found to be 2 meters per second square. Mb plus Mc, 10 plus 6, 16 into 2 is equal to 32 Newton is a tension, right? And NC, the normal on the block C is 60 Newton. Why? Because C has a mass of 6 kg. So the normal on the block C is 60 Newton, right? Then depending upon the how much is the frictional force? Frictional force is mu into NC, right? So how much is that? Suppose it is half into NC is 60. This becomes 30 Newton, right? So if the frictional force is 30 Newton, no, let's take more because otherwise so you say overcome kar jayega. Suppose it is 0.4, no 0.4, 0.6, then 36 Newton. Suppose that mu is 0.6. Let's take various cases. So if mu is 0.6, then NC is 60 Newton. So the is calculated to be 36 Newton. And the force applied on the block C due to the tension in the rope is 30 Newton. So it is not able to overcome the friction. So C and B will move together. In case mu is lesser, then in that case F might come out to be lesser. So in that case, what will happen? In that case, B will not move, right? Suppose you take mu to be 0.4, then F will be 0.4 into 60 is equal to 24 Newton, right? So this force, which is F, right, between the two surfaces is only 24 Newton, right? In that case, tension is going to be, the pulling force on C is more. So it overcomes the tension. So only the block C will move, then the block B will not move, right? Although block B is lying on a smooth surface, but it will not move because now both are not joined, right? So it all depends upon the quantity of friction or the frictional constant, right? Should I continue with another problem? 437. Actually, I wanted to touch a variety of problems because, of course, you know, there are hundreds of problems in various books. So I wanted to take up problem from each area, like inclined plane or two blocks lying on a horizontal plane, then less friction or more friction, so that when you do practice from your worksheets or even from that book of Udaan, so you have some idea that how the problem is to be tackled. So I have another problem, slightly different, which I'll introduce. Okay. Instead of noting, it will take some time. I'll first speak the problem so that you understand. A small block is resting on an inclined plane. A small mass is resting on an inclined plane where the coefficient of friction is greater than tangent theta. Right? What does it mean? Coefficient of friction is greater than tangent theta. We, when we were learning about angle of repose, we learned about a relation between angle of repose and the coefficient of friction. Remember? Go through your notes. Mu is equal to tangent theta, right? That was the definition of mu. Could write angle of repose or tangent alpha. We had defined that as alpha. And when theta was greater than alpha, right, then the block will slide down, otherwise it will not slide down, right? So depending upon, so there was a critical angle. So there was a critical angle, mu is equal to tangent alpha. When the angle is alpha, then that is how we define angle of repose. And when the inclined has an angle more than the angle of repose, the body will slide down. Otherwise, the frictional force will be more and the body will not slide down, right? Okay. So a small block is resting on an inclined plane, coefficient of friction m greater than tangent theta. The inclined plane is given a constant horizontal acceleration towards right. The whole inclined is moved rightwards with an acceleration of a. Find the range of A such that the block does not slide. Find the range of A. Does not slide. Find the range of A so that the block does not slide. Find the value of A find the value of A such that the friction between the block and the plane is 0. I see. So I have to stop maybe 2-3 more minutes then. Right? Now to solve the problem, you will always have the mass, because the weight of the body, right, on the inclined plane, a downward force of mg, which you can resolve into two components, mg cos theta and mg sin theta, right? Right, frictional force. Now the whole block, the whole inclined plane is moving horizontally rightwards with the acceleration a. So on the block of, if the block has, of course I assume the block to have a mass small m, so a force ma will act on the block. So in a way, the block is moving with the acceleration a, right? We'll have to apply Newton's second law. Newton's second law says that calculate the net force on a given body, that will be equal to ma, right? But here we have to see that, see, the block has to, we are assuming that the block moves along the incline only. So what we do is that we resolve this force ma, which is acting horizontally on the block, into two components, one along the incline and one perpendicular to that. How much will be these two components? It will be ma cos theta and this will be ma sin theta, right? If there is no confusion, we can write equations. Okay, let's write the equation along the normal direction, right? How will you write equation along the normal direction? mg cos theta and n. So n minus mg cos theta. Is it all right? Is equal to ma sin theta. And along the incline, how will you write the equations? mg sin theta minus f, no? Along the incline, mg sin theta minus f is equal to ma cos theta, right? And what is f? F is mu n, right? And mu into n. N is mg cos theta, right? So this becomes mg minus f, mu mg cos theta is equal to ma cos theta. One equation was this, and here also one can substitute n, no, not n, n minus mg cos theta No, you can't take n is equal to, because otherwise that will cancel. N minus mg cos theta is ma sin theta, and f plus mg sin theta is equal to ma cos theta. F plus. Here it has to be plus, right? Here it has to be plus. Please make a small change. See, basically, when you see there is an inclined plane, there is a block. When you will move the block horizontally, the block would like to move up. You understand? When there is an inclined plane on which a block is lying at rest. So as the inclined plane will move horizontally, the block will move upwards, right? So if the block move upwards, the frictional force is going to be not in this direction, but downwards. So it has to be plus, right? It has to be plus. ऑलरेडी है हाँ नहीं चलिए बता दीजिए okay we'll just take up yeah why the frictional force increases when the two surfaces are why frictional force increases when the two surfaces are extra smooth? No, it decreases actually. No, actually the frictional force decreases with smoothness of surfaces, not increase. Possibly the question could have been that before, during the static friction, when you are applying external force, we say that the frictional, as you apply external force, the frictional force increases. That could be a relevant question. I expected that question, that when you are, it is something like, suppose you, there is a child whom you want to take with you, you hold his arm and pull him. When you pull him slightly, he pulls you back slightly, and as you pull him more, he pulls more. He is not moving till the end. Finally you are able to pull him, finally you are able to take the frictional force. But when you are pulling him, as you are wearing the force, he is also wearing the force, he or she, right? She is also trying to pull you back, and the condition is static, right? Of course that is not the answer here, but I just thought of an example where friction and the external force are equal till the static conditions are there. Of course, in kinetic conditions, it is different. See, basically, as I told you that it is due to the bonding, intermolecular bonding, right? And it is electromagnetic forces. So the molecules of adhesive forces, you understand adhesive forces? Adhesive forces are between two different, forces between molecules of two different materials, right? And these are, see, when you look at, see, a molecule is normally a neutral charged body. But when you look at the molecule at a microscopic level, right? So there are properties which are called macroscopic and microscopic. But when you look at the microscopic picture of a molecule, it contains different ions, right? Different atoms, like if you take a water molecule. So when one molecule of one material is near the other molecule, there are electromagnetic forces between them, right? And because of these electromagnetic forces only, the friction is there, right? So when you try to pull, and there is a bonding, so it is not that simple, it's complex. There is a bonding between the molecules. So as you try to apply force, the bonding is stronger. But once, as I told you, that there is a limiting force, after the limiting force the friction becomes lesser, so the bonding is not that strong after you pull. Because basically, see, it is just like, see, see, there is a gravitational force acting on this block. So suppose that it had been heavier mass, so if I apply a force to lift it, I am unable to lift it, so I have keep on increasing the force. And as soon as my force becomes greater than the gravitational force lying going downwards, I am able to lift it, right? So you have to keep on applying a force which is more, when you reach the limiting force, then you can lift it, right? Okay, right. Why the frictional force of B and C are in opposite directions? Because of Newton's third law. Newton's third law, because one moves in one direction and the other is in the other. For every action, Newton's, that's why we studied Newton's laws quite in detail before taking up all these problems. So Newton's laws are basic and they will always come in picture, right? Okay, please explain the free body diagram of B and C. It was which diagram? I think it could have been right? So when you take free body diagram of B, then here the weight of the body is downwards, and how much is the weight? mbg, right? And the normal acting on the body is named as nb. And then there is an external force and there is a frictional force, because when the force on the body B is applied rightwards, it likes to move rightwards, so the frictional force will go leftwards, and the external force is rightwards. And normal and weight are very obvious. And when you take the free body diagram for C, then the weight of C is mc into g. And then due to the reaction NB, there is a downward force NB also. Again, one can say Newton's third law, right? So since, or the other way is that since the two bodies are in contact, so they are exerting force on each other, right? So NB is a force on B due to C, and here this NB is a force on C due to B. There's an easier way to understand, since the B has a weight mb into g, which is lying on the, which is pressing the body C downwards. So therefore nb is equal to mb into g. So this much force, like it could be considered this, right? Although it could be reaction to this, right? So this force of B is acting on the upper surface of C, so it is downwards. And then the frictional force, right? Because here F was opposing the motion of B rightwards, so it was leftwards, right? And here it is on the block C surface. On the block C, it is rightwards, and there is no external force. So that is a free body diagram of the body C. Actually, see, in fact, since we didn't have much time, you all must be knowing that how we walk actually. Walking is, I mean, it's not actually, friction is slightly notorious. We say that it is always opposing motion. It is not. Actually, it gives us motion. We are able to walk only because of friction. So friction has good applications also. So as we move, as we walk, basically, as we walk, somebody is walking, then he is pushing the ground backward, and the friction is moving it forward. So we push the ground backward, and why we are able to push up? If it had been smooth, we will not be able to push it. Then we will actually slide back or slide ahead. Because of friction, we move the ground backward, and the friction. So the force has. So when two things are in contact, the two forces acting on each other are not in the same direction. They are opposite to each other. So that's why the frictional force between B and C, on B it is leftward, on C it is rightward. Next question. Does train travels also due to rolling friction? It is not exactly that train is traveling due to rolling friction. It has to overcome the rolling friction, and it is a force, external force, which is applied on the train due to, of course, the engine, which is moving it. But it has to overcome rolling friction. That is what one can say. More questions? There are more questions. Example 10 on page 162. That is what I took, the example I took. So that question, in fact, I have taken in the class only. Yeah, this question we solved. अभी आज इंट्रोड्यूस लेक्चर we solved this question. Example 10 on page 162. That question, in fact, I have taken in the class only. Yeah, this question we solved. Abhi aaj in today's lecture we solved this question. Yeah, the same question was solved in the class. So maybe the student had asked earlier. Otherwise, they would have come to know that I've solved this question. Why kinetic friction is always less than the static friction? Because because right. This why the kinetic friction is always less than the static friction. Static friction cannot be less, right? Because otherwise, if the kinetic friction is more, it will not move actually. It will not move. And as I, in fact, towards the end of the lecture, I explained also that why there is a limiting value, and after that, the when the body is in motion, it becomes lesser because the bonding is now, because once you are able to move the bonds, because earlier it is because of the electromagnetic force they are trying to pull each other, right? Question number 13 on page 166. 13 166. In an arrangement 12 and 13 both, if force F is increased with time and at is equal to F is equal to, where will slipping first start? Between 3 kg and 2 kg, between 1 kg and ground, between 2 kg and 1 kg, both A and B. So we can actually calculate the normal. Mm, 12. You said 12 and 13 both, no? 10 and 13. Okay, so not 12. Okay. In the arrangement shown in the figure, mass of the block B and A is 2m, and B and A is 10th question on. No, 166 ही होएगा, 162 पे तो 10th क्वेश्चन है ना, वो तो हो गया, एग्जाम्पल 10 ऑन 162 हो गया, वो तो हो गया था, फिर 166 पे 13th I see, yeah, that's no 13th I have not solved. In the arrangement shown in the figure, mass of block B and A is 2m and m respectively. 2m and m. Surface between B and A, B and floor is smooth. The block B is connected to the block C by means of a string pulley system. If the whole system is released, find the minimum value of mass of block C so that the block A remains stationary with respect to B. Have solved a similar problem. Similar problem we have solved, but this problem looks to be slightly wrong because A, he is not showing above B, is showing on the side. It is not going to stick there. If you look at problem 13 on page 166, the mass A is lying adjoining mass B. It is not going to stay there because of its own weight. It is going to fall. Can you please explain example 5.9 on page 102 of NCRT? NCRT. Yeah, बताइए. Page number 126. नहीं, ये I couldn't do actually. This I've tried, but maybe I'll solve it next time, because when you resolve at the points A and B, when you resolve, you get components mg cos theta and mg sin theta, where mg sin theta components, mg, if you take this way, yeah, mg cos theta components will be horizontal and mg sin theta components will be vertical. Because look at here, that they have drawn the tangent at the point A and B. Look at the dash line which is tangent, right? If you draw the tangent, let's call it tension T, because tension is everywhere tangential to the root, right? So at the, let's take as an example point A. So the tangent is going obliquely down. If you resolve into two components, T cos theta will be horizontal component, T sin theta will be vertical, right? Because adjoining side is the, right? So T cos theta at A and B will be this way, and T sin theta will be downwards, right? So the two components will be T sin theta downwards. Question number 4. A block of mass M is suspended as shown. String AO and OC are horizontal. AO and OC. AO and OC. C he has not shown. Are horizontal and vertical respectively, right? OC is downwards. Or vertical. Ratio among the tensions in the strings T1, T2, T3 will be. So one can find, yeah, in fact, we have to solve it. One can resolve into, I think, I see, because T3 is, if you resolve into components, then one equation this side, one equation this side, and one will be due to the mass of the string, like T2 and mg. So T2 will be mg, no? And then so this is basically T3 cos theta, and this is T3 sin theta. Now T3 cos theta is T1, and here it is T3 sin theta is equal to T2 plus mg, no? No, is equal to T2 only. Okay. Okay. Is there any direction for static friction? Yes, static friction. All the directions of the friction is same, always same. Wherever the two surfaces are meeting, that gives you the direction of the friction. That gives you, so static or kinetic friction always same along the contact line, along the line of the contact, right? Pardon? Okay, thank you so much. Now today's class is over. Okay. Okay, yeah, fine. Thank you so much.